And the third of the parameter is there. Here in this wastewater treatment, while using the orgasm, what about the growth principle of this orgasm? So this growth principle of the orgasm is very important in this handling of the biological waste treatment. Because this growth principle, what happen? Sometimes the termination of the growth is there in this wastewater treatment plant due to the exhaustion of the nutrients, accumulation of toxic metabolites in this wastewater, or dropping this pH in this wastewater here by certain chemical reaction. So at that time, the termination of growth is there. So that here to avoid this effect, here the continuous growth system are operated by regulating the feed rate and regulation feed rate and also the removal rate. So usually, so this continuous growth system here usually occurred by growing here by using this mixed culture. Usually, the growth in the mixed culture is more common in the wastewater treatment, in the effluent treatment plant or effluent treatment system than the monoculture or the single culture. The selective culture is not to be used because it has certain limitation. If the condition becomes adverse, so this culture is not working in the treatment process. Therefore, you can use the mixed culture. Because why you can do mixed culture? Because this mixed culture, yeah, in which there is a complex interaction. So all these mixed culture, they have the complex interaction and complex relationship. And being this complex relationship, they are living together and working together and also the efficiently working in the same treatment process. Therefore, the mixed population culture is to be used in the wastewater treatment. They are by consideration growth principle. Because if you can use the individual organism, here this individual organism is not working. So therefore, you can use this mixed culture. And the another, if such mixed culture are also not applicable, the next part is there. Next part of the organism you can use in the wastewater treatment as a plasmid for metabolic activities, because the plasmids, they are extra chromosomal DNA present in the bacterial cell, and these plasmids, they have some special characteristics. So usually some organisms, they produce plasmid, they have the metabolic activities, or these plasmids, they have the metabolic activities like degraded activities. So they also have the additional characters like the resistance drugs as also the antibiotics. And among these same organism using in this way such uh, plasmid containing organisms, here you can use in this wastewater treatment. Usually the most common organism, that is Pseudomonas. So these Pseudomonas is the prominent organism. Here it has the plasmid, usually that's the degraded plasmids. And in that degraded plasmids, some special plasmids produced by the certain organisms, like the CAM plasmids, OCT plasmids, as well as tool plasmids. So these certain plasmids, they are produced by, they are having this by this bacteria, usually the Pseudomonas. And these plasmids here, they are used to degrade certain complex organic compound here, which are not actually degraded by certain common organism. So this CAM plasmid, it acts on the campone. The OCT plasmid acts on the acetone, octane, and the tool plasmid, here it acts on the toluene. So the another part is there, physiology and important organism used in the wastewater treatment. So besides this physiology wastewater, the important organism, again, in that same, what is the actual growth principle of the organism in this wastewater treatment? On the acquisition growth principles here, you can supply this nutrient to the organism, and these nutrients by inducing nutrients, so these efficiently work in the wastewater treatment. So such part is there, that the physiology and important microorganisms in the wastewater treatment. And the next part is there in the same wastewater treatment. Here, what is the next part? That the impact of the pollutants on the biotreatment process. Because if the the pollutants are there added in the wastewater, so these pollutants, they have certain impacts on the biotreatment process. And these impacts that conserve inhibition of the biodegradation. And this biodegradation inhibition is also there usually by heavy metal in the wastewater. Here inhibits the biological activity. The phenols and pesticides present in wastewater here inhibit the biological activity and treatment plant, as well as the volatile compounds in the wastewater. They also become toxic to the treatment plant. So by this way, the inhibition of the biodegradation is there. And if the inhibition of the biodegradation by certain activities, that also help in the wastewater treatment. Then second part is there, incidental removal of pollutant. And these incidental removal of pollutant usually occur by the absorption, adsorption, precipitation method. So such incident removal of the organism, that also help in the wastewater treatment. Okay? So these are the indirect mechanism. Inhibition of the biodegradation is the one of the part of the wastewater treatment. Then here incident removal of pollutant from the wastewater, either by absorption or by adsorption or by the precipitation. Some of the toxic chemicals, some of the pollutants are there. They are readily absorbed by this chemical compound or by the chemical compound or absorbed on the solid surface. So by this way, doing this washing and cleaning, so these absorbed as well absorbed compound, they are removed here from the wastewater, and then the treatment is achieved. So such impact of the pollutant on the biotreatment process. So such parts are there in the same in the impacts of the pollutant on biotreatment process. The next part is there here, the methods of the industrial wastewater treatment, part 1, and these methods, even such biological methods are there, but some methods are there to treat this wastewater before discharge of wastewater in the discharge of wastewater in receiving stream. And in that this treatment process, physical method, some prominent examples are there, like this one, neutralization, oxidation of the cyanide, then chromium reduction, carbon adsorption, then reverse osmosis and distribution of the phenolic compound. Among these all these physical methods, the neutralization is the most common method, because usually the waste which is generated, so first the waste is to be analyzed whether it is alkaline or acidic. According to this analysis, here you can use the treatment process. Here, if the acidic waste, it is treated by separate method. If the alkaline waste is there, it is also treated by the separate method, so to neutralize the waste. But in this neutralization, one part is also there. One of the method is there. Here, you collect the waste from the waste generated from here acidic waste generated from the one industry, which are the acidic waste, and the second waste generated from the second industry, which is the alkaline waste. So both wastes are to be collected, and both wastes they are to be mixed here intermittently. So by this way, the atomic treatment is there, the neutralization is there, and then here the waste treatment is also assured. So such methods are there. Then second method is there, oxidation of cyanide. So here this oxidation of cyanide. So the toxicity of some contaminants can be reduced or completely destroyed by the oxidation of the pollutant. Usually the cyanide is removed by this oxidation method, because this cyanide is lethal to the lethal to the organism while combined with the acidic waste. So it is removed in the two stages, the first stage and also the second stage. In that first stage here, these cyanide waste, here you have to raise the pH up to the 10 to 11. High addition of NaOH together with chlorine and sodium hypochlorite. And in this first stage, the cyanide is converted to cyanate, that's the least toxic compound. And then second stage is there, the further addition of the chlorine or hypochlorite with equal quantity. The pH is controlled between 7.5 to 8.5 by addition of an acid, that the acid, and this reaction further oxidizes the cyanate to the harmless CO2 as well as nitrogen and also the salt water. So by this way, you can treat this waste contains the cyanide here in the two stages, the first stage and also the second stage. So to get the simple compound, the CO2 and here nitrogen and also the salt. The second part is there, the reduction. So this reduction, that the chromium reduction. The chromium is treated by reduction where the hexavalent chromium, hexavalent form of chromium is converted to trivalent form. So this trivalent chromium is to be removed by precipitation method. Yeah, precipitate as the hydroxide. Okay, so such chromium reduction is there. Another method is there. This chromium reduction, again, it occurs in the two stages. the first stage and second stage, where the final stage, the chromium hydroxide is formed, and this chromium hydroxide is precipitate and it can be removed by the separation method. The next part is the carbon adsorption. It is mainly used for to remove the dissolved organic compounds in the wastewater, the saturated oils, alkenes, then chlorinated hydrocarbon, dyes, phenols, as well as benzenes. As well, it is also used for to remove certain colors, odors, and the taste from the wastewater. So these absorption methods, they are used to remove color, all these compounds. In this method, it is based on the principle of the charcoal filter, where the activated charcoal is filled with this column through which the waste is allowed to pass. And then, so the method that serpentation of the activated carbon particles causes the molecules to adhere on it. So the principle of this absorption method. Yeah, so that the greater the surface area provided an activated carbon column, the greater will be the number of adhering molecules here from the wastewater on this same carbon activated carbon. So such after this when the process is completed, the exhausted activated carbon here, it is not to be discarded. Here it can be regenerated. What is actual regeneration? Here here you have to survive that. You can reuse that by incidence same activated carbon here. It in the absence of oxygen, that the 1905 degree centigrade. So such regenerated activated carbon can be also reused for the next batch of this carbon adsorption method. And the next method is there here. It is the reverse osmosis. It is a comparatively new treatment process in the wastewater treatment that separates the pure water from the certain pollutant. Actually, the meaning is there of this osmosis. Here you can separate the pollutant, but here in this method you have to separate the pure water from the pollutant. So in this method, it is the membrane permeation process for separation of relatively pure water. So this separation, the membrane filter operation is called as hyperfiltration or superfiltration. The method requires high pressure to be applied to force out the liquid, that the pure water, through the semi-permeable membrane by leaving behind the dissolved solids or the pollutants in the same wastewater. So this process is the reverse osmosis. In this, the semi-synthetic permeable membrane mainly used and usually made up of the cellulose acetate. But this membrane, it has this operation. It is operated at the typical atmospheric pressure, that the 40 to 50 atmosphere pressure, and then it flux water is about 10 to 20 gallon per feet per day. What is called this the membrane filter or this cellulose filter? It has the typical the operating system. Here this pressure is to be given to the same filter 40 to 50 atmosphere, and how much water is to be treated by the same filter? Here it is about 10 to 20 gallon. So such adsorption method is also there. You can use for to remove treat this in wastewater. And besides this same adsorption method, the here the phenol destruction method is also there. The phenol destruction, usually the phenols, they are aromatic compounds, and these phenols, they are reconstituted compounds. As little as 0.005 milligrams per liter of the phenol can impart the objectionable taste and odor to the drinking water. When it combines with the chlorine, the phenols have relatively high oxygen demand. Here, near about 2.4 milligrams of the oxygen per megaton phenol. So this phenol removal below the 1 milligram per liter is accomplished by multiple treatment process. Usually, the phenol oxidation is there by the same to remove phenol from the wastewater. So such here methods are to be used. Physical methods you can use to treat this wastewater here by in the part 1. So this is the unit number 1, unit number 2. The third unit is there here, the methods of the industrial wastewater treatment. In the third unit, here, these methods usually industrial wastewater treatment part 2. So this method, this part 2, it includes the biological methods totally. And in that biological methods here, the first activated sludge process, Second, the trickling filters. And the next part, methods of the industrial waste treatment. Part 3, again, the biological method. Second, that the lagooning process. So aerobic lagooning, anaerobic lagooning. So what are actual lagoons? So what are actual dimensions of the lagoon? So how much wastewater is to be added in the same lagoon? Then what actual retention time? Detention time in the detention of wastewater in the same lagoon. So all the points are to be discussed to the student with this in the same lagooning process. So this is unit number 3. Here, the methods of the integrated wastewater treatment. The biological method, part 1, activated sludge process. What actual activated sludge process? What is actual activation? You have to discuss to the student. Then what is actual sludge? Then in this same activated sludge process, what is the actual principle of an activated sludge process? Then what is actual method, actual process of the activated sludge? Then what organisms are involved in the same activated sludge? And here, microorganism sludge bulking process. So all these points are to be here clear to the student regarding biological method part 1, that the activated sludge process. The second part, which are second method is there in the activated sludge treatment part 1, that the use of trickling filters. So what is actual trickling filter? Then what is actual principles of trickling filter? What is actual working of the trickling filter? Then method of the trickling filter, operation of the trickling filter. Then what organisms involved in the same trickling filter? Usually, so these trickling filter where it is a sand bed, and this sand bed you can use here to percolate the sand waste to use same trickling filter. So actually, the fountain-like structure is there. So this, the waste wood is to be there. So this waste is to be allowed to here sprinkle over on the sand bed, and these sand waste water start to percolate through the sand bed through the porous material, and after that, then while percolation, certain layers are formed. The first, the gelatinous layer is formed on the same sand particle, and then on the same gelatin layer, here, the second layer is there, the microbial layer. And this complex layer, it is called zooglia. So these zooglia, it contains the organisms, and these organisms, they carry out decomposition of this organic matter in the zooglia layer. And then finally, the simple products are formed. And by these simple products of this organic matter, that the CO2 as well as H2O, so they come at the bottom, and the treatment, then the treatment is occurred. So such trickling filter is very important in the treatment of wastewater by the biological means, in which how the biological means, because the microbial layer is there in the same trickling filter or in the same trickling filter bed. The second part is there, the biological method here. Second, that the lagooning processes. In that lagooning process, here you have to keep the waste in the lagoon. Yeah, lagooning. So this method usually aerobic as well as anaerobic lagooning. So this method, biological method, generally used in the treatment of the waste water. Yeah, treatment of the waste water if the land is available. If the land is not available, you can use the alternate method. But if the land is available, then you can use the lagooning process. So this lagooning is of the two types, the aerobic lagooning as well as anaerobic lagooning. And in this aerobic lagooning, what actual principle of the aerobic lagooning? Whatever lagoon, whatever this size of the lagoon, depth of the lagoon, and how much waste is to be added in the same lagoon, and what is actual detention time, up to what time you have to keep this waste in the lagoon, so to reduce the BOD from the same wastewater. The main principle in this wastewater treatment, anyhow you have to reduce the BOD. Anyhow, you have to reduce BOD either by retaining this wastewater in the lagoon, yeah, or by passing this wastewater through activities process, or by this trickling filters. So this is the lagooning process, that the anaerobic lagooning, aerobic. The second, that the anaerobic lagooning. So this here, what actual anaerobic digestion? The principle of anaerobic digestion. In this anaerobic digestion, the anaerobic microflora is working. So what actual method of this anaerobic digestion? Then biogas formation. What actual biogas formation? How this biogas formation is there? Then what reaction mechanisms are there? And so this biogas formation here is also the one of the best example of this wastewater treatment. And if the biogas formation is there, so these biogas, it has the certain applications. So such here unit 3 here biological methods as well as here biological methods, biological method 1 and biological method 2. The next here unit number 4 here the next part is there, the unit number 4. And this unit number 4, it includes the 4 subtopics: bioaugmentation of the industrial waste treatment of the specific industries, the here, zero waste discharge concept in the industries, and waste disposal control and also the regulation. So among these same here, the biomanagement and wastewater treatment. And in this biomanagement of the wastewater treatment, in that the first topic, biomanagement of the industrial waste. In this, the technological options for treatment of the liquid as well as solid waste. And in that technology options, here the some sub points are there. Bioaugmentation, package organisms, use of genetically engineering organisms in the wastewater treatment. So in this same topic, what is actual bioaugmentation? So in that bioaugmentation, it means the use of the blends in the treatment of the wastewater. So in the bioaugmentation, there are two ways initiating the microbial activities in the treatment process. The first, that the bioaugmentation, where this bioaugmentation involves initial bacterial formulation externally to the wastewater treatment plant or polluted sites on the land or the groundwater. So these bacterial formulation. So these bacterial formulation consist of freeze-drying bacterial culture or freeze-drying fungal culture, fungal pure culture, blend along with the certain additives. So such mixed fungal culture or this bacterial culture, along this pure culture, along with this additives. So this blend you have to make that, and this blend you can use. It is to be freeze-dried, and this blend you can use for the wastewater treatment. The freeze-dried bacterial for suspension generated from some pure culture, then blended to produce a mixture of the several species together with additives. The dosage used initially in the few kgs, the repeat dosage is required in the small amount to make up the loss of the culture during the treatment process. So these are the principles of bioaugmentations. The microorganism capable of degrading of the herbicides or the other chemicals in industrial waste are isolated from the same wastewater or also from the sludge and also from the compost. And then among these same organisms, some strains may be eradicated to enhance their ability, and then the mutants are selected. Then before their use in the treatment setting, they should be tested in the lab for their biodegradability. So such selective organisms is added in the reactor, but due to the trade secret, the formation in the bioformulation and the mixed culture are not to be disclosed. So this is the principle of bioaugmentation. And in this same principle of the bioaugmentation, here, this bioaugmentation, here, it has the many applications generally used to increase the BOD, remediation treatment plant. So this bioaugmentation, here it is generally used to reduce the sludge volume by the 30%. Also using the biotreatment hydrocarbon wastewater, and also using the biotreatment of hazardous waste. So doses are there. The most important examples are there. Here some examples of bioaugmentation. So these bioaugmentation, the use of the ideal mechanism for treating the hazardous waste, such as phenol, xylene, glycol, as well as the formaldehyde. Another example is there, bioaugmentation with the parachlorophenol degrading bacteria. These bacteria, they degrade 96% of the paraphenol within the 9 hours. Another example of the bioaugmentation here, the cells of Candida tropicalis have been used for removal of high concentration of phenol present in the fresh water. So such bioaugmentation, the second part is the biostimulation. So what is the second part of the biostimulation? It makes the use of the existing organism and make the condition favorable for them. It means that here you can stimulate the biotreatment process by making the suitable condition for existing organism, and make this organism charge to treat the cell waste here by the cell biological way. So in that cell same bioaugmentation. Another part is there here some besides cell organisms, some enzymes are to be used in the bioaugmentation like this one. Several enzymes have been detected in the cell wastewater, such as catalases, phosphatases, as well as to the aminopeptidases. So these enzymes they are to be added here to the wastewater to improve cell biodegradation. And some enzymes are there. Example, in that enzyme, parathion hydrolysis enzyme produced by certain bacteria like the Flavobacter and also the Pseudomonas. So these the enzyme, they have been used to clean up the containers of the parathion and detoxification wastewater contains a high concept of organic phosphate. There is another example of the enzyme you can use the fungal lacages, which produced by Botrytis cinerea, and it can be useful for the treatment of the certain effluent generated from paper and pulp industries. Here, because this enzyme can be useful for dechlorination of chlorinated phenol compound. As well as the another enzyme is also used in the cell bioaugmentation program. Here, the specific enzymes like this horseradish peroxidase enzyme can catalyze the precipitation of aromatic compound. Here, so such bioaugmentation here you can use in the cell treatment process. So this is a bioaugmentation of the cell internal wastewater treatment. Then use of the package organism in the cell wastewater treatment. So some package organisms are to be used in the cell wastewater treatment for here this package organisms in this same wastewater treatment. Then another use of the generically organisms in the wastewater treatment. So if such bioaugmentation is not possible, then you can use a package organism. You can use a mixed package of this organism. So this is a package, yeah, they are usually generated by some entities. And these package, these packages of them, they are generated from the entities, usually from the foreign countries. We are not aware of this and the same use of cell package organism in this industries to treat the waste by the biological way. Yeah, this is another option. If the biological treatment is also not possible, if the physical treatment is not possible, yeah, you can use the bioaugmentation is the one of the here technological options, or you can use the package organism, you can use the pack of the organism. Here, aerobic organism pack, anaerobic organism pack, here pesticide degrading, 2,4-D degrading the organism. So this pack you can use that, or use of the genetically engineered organism in the wastewater treatment. So such options are to be used in the treatment of the wastewater. So this is another part here in this unit, the first unit, first part, biomanagement of the industrial wastewater. The second part, industrial wastewater treatment. The methods of the treatment of the wastewater from dairies, distilleries, paper and pulp industries, and fertilizer industries, and pharmaceutical industries. Because in this wastewater treatment, here this industrial wastewater treatment, the use of the water is required for different industries. So we have the three alternatives for the disposal of industrial wastewater: directly dispose waste into the stream without treatment, or dispose the waste into the municipal sewer with a combined treatment, or separated the treatment of the different industrial waste before discharge in the discharging in the same into the wastewater in the water. So the treatment process depends on the various factors, and these the various factors that the seal capacity of stream. It is also based on the permissible levels of pollution, pollution to water body, established by certain law. So what is actual permissible limit? How much this steam water permit the certain wastewater with this high BOD, COD, pH, as well as here total suspended solid. So all these points that are discussed in this table. Here it is in this book. Here, water pollution causes, effects, and control by P.K. Goel. So such table is there in this limits for the steam water steam water to steam water to get this wastewater. So such limits in terms of the BOD, COD, pH, temperature limit, oil and grease limit, as well as also the phenyl compound, then also the sulfide containing. Usually the tolerance limit for the industrial effluent in the inland surface water in terms of the BOD 30 milligrams per liter, in terms of the COD 250 milligrams per liter, in terms of the pH, the pH of the wastewater should be in between 5.5 to 9. It should not be increased. So such permissible limits of the wastewater are there. So using this and the same permission limits, then the broadly so before training and the same this wastewater treatment. Yeah. So all these and wastewater are to be classified in the different classes. Yeah. The organic substances that deplete the oxygen, which contain the receiver water, stream water. The second, the inorganic substances like this and carbonates, chlorides, and nitrogen. So such categorization is there, such analysis is there. So what type of the content is there in the wastewater? According to the same content, you can treat the wastewater here with the special methods. Then some industries that are producing this wastewater, here producing waste, like this paper and pulp industry, it has the strong color, high BOD, high alkaline, high sodium content, and it is treated by chemical recovery, surface treatment process, chemical recovery treatment, line treatment for color removal, and biological treatment. In that biological treatment, all the methods are there. Here, two-stage biological method, as well as also this aerobic lowering, anaerobic lowering, all these methods are to be there. Then the second industry is there, that the tannery industry. It has the strong color, high salt concentration, as well as also the high BOD, high dissolved solids, presence of sulfides, and here. So this waste is to be treated by chemical treatment and also biological method. As well as the distillery and brewery waste, strong color, high chlorine content, high BOD, and it is treated specifically by biological method. Then another industry waste is also there, the dairy industry. So this dairy industry, it has the high dissolved solids, high suspended solids, high BOD, presence of oil and grease. Again, it is also treated by the same biological method. So such methods are, as well as some distillery industry and brewery industries. It has the strong color and high chlorine content. It is treated by biological method. Then another waste is also there here, like this one, fertilizer industry waste. So these fertilizer industry waste here, it is treated by the typical method. What is actual typical method for the fertilizer industry waste? Here, these fertilizer industries. Fertilizer industries, some treatment processes are there because these fertilizer industries, here it has the toxic waste, and these toxic waste is treated by chemical way, as well as also by the biological way. So then the pharmaceutical industry waste is also there, or the chemical industry waste is there. It is treated by pharmaceutical industry waste. Yeah, this waste, like the other industry, it produces the wide variety of products and it uses the both organic and inorganic organic materials here as the raw materials. Some pharmaceutical plants do not discharge the liquid waste. Some may produce a very small and waste, but the constant liquid waste is there. Some waste may also produce the high alkaline or toxic liquid waste. Therefore, it is very difficult to characterize. In general, the antibiotic as well as vitamins that are produced by fermentation of fairly complex nutrients by fungi and also bacteria. Whereas the penicillin, it is obtained by using the penicillium calcium by using the CSL as a nitrogen source. Where the streptomycin, it is obtained by the Streptomyces gracilis by inducing a substrate of the glucose and CSL. The liquid waste from the antibiotic plant may be divided into different groups. Spent liquor from the process, wash water used for the cleaning process, the waste with the acids and also the solvents, and also the filter aids. Yeah, filter aids, where the filter waste water is also there, and the condensate water is the another cooling water system which is obtained from the cooling water system. So these components are there in the antibiotic plant waste. So such antibiotic plant waste is treated here by typical method. The first, the antibiotic waste are here neither clarified in the settling tank, nor chemically coagulate to reduce any BOD. Here, because pure responsible coagulation is there, that's fine. Here, it is not to be coagulated and to reduce any BOD. The second step is there in an antibiotic based treatment, anaerobic digestion waste. It results in the good reduction of BOD. And in this, inflow of the waste, raw waste is controlled, not to be exceeded 10-5% of the capacity of the digester. The another point is there aeration of waste. It is seeded by here domestic waste or garden soil, produce and BOD. And another method is there in the antibiotic waste treatment, that the use of taking filter method. This is where here it produces the good BOD reduction. Here it is also helpful in the color removal. Here by the taking filter method. So such antibiotic wastes are treated by the same biological means as well as to this as well as also the chemical means. In the same pharmaceutical waste, pharmaceutical industries, the second category is there here synthetic drug waste from the same pharmaceutical industries, and these synthetic drug wastes, they are chemically toxic. The synthetic drug plants utilize the large numbers of both organic and inorganic chemicals. Here, the volume of the waste not only varies from the plant to plant, but also section to section. In general, the most of the waste, they are toxic to the biological life and usually characterized by high BOD, high COD, high COD BOD ratio. So such waste, they are either highly alkaline or highly acidic. So such these wastes have negligible fraction of suitable solids. So such wastes, they are to be treated by this biological means as well as to the chemical means. So such methods are there in this wastewater treatment. The special methods for each and every industries. Here, the separate methods are there. For the industry, the two-stage biological method is also there. For distillery, the paint wash is there. So this paint wash is also treated by biological means. Paper and pulp industries, here it is treated in the different ways. The most important method here, the massive line treatment in the treatment of paper and pulp industry waste. So such important processes are to be there in the treatment industry waste. The zero waste discharge concept in industries. Yeah. So these zero waste discharge in the construction industries. Yeah. So all the industries, all these waste need to be treated properly, and then these waste to be added in the waste in the steam water. So you can design the industries so to discharge waste with the very low volume. And the next part is there, the fourth part, the waste disposal control and regulation. For actually this waste disposal control, water pollution control, and in that the water pollution control, regulation limits for the disposal into the lake and also this rivers, oceans, and lands. So in that water pollution control, it seems to under the control as the quality of the natural water. So in the water pollution control, certain forms of the water pollution controls are there. The water pollution. The water pollution is described as the loss of practical usable water. Here, due to the contamination, it comes in the many forms. The natural contamination, man-made contamination, and all these forms, the kill the natural habitat as well as also the wildlife. Some forms are there. Here, like the industrial surface runoff from the solar farms, splash and burn farming practices, excessive nutrients spilled into the into the water from the solar factories, acid rain, accidental leakage from the underground storage tank, and discharge from the industrial processes. So such forms, the forms of the water pollution control. To combat the water pollution, there are several forms of the control have been implemented, and these forms of the control come under the government level authorities. The legislator, the laws and acts that that limit how much contamination can be allowed it back into the natural fresh water sources. Here, and it's under the Clean Water Act. Here, Decency Act under EPA. So such water pollution, here it is the forms of the water pollution control by here legislator. The second, water recycling is the one of the way of this water pollution control. Another practice for the reducing water pollution is the water recycling. It involves the taking this water, wastewater, and retreating it so to use for irrigation. It leads to prevent the loss and wastage of water. The repeat pre-treatment is there, and then this repeat pre-treatment, repeat treatment water here it is used for recycling. The next is the water conservation. It is an important part of the controlling water pollution. Due to this practice, the conservation, there is the less runoff of wastewater into the natural habitat. Water you have to conserve. So if the water is conserved here, here you can able to limit this water in the wastewater, limit this water in the wastewater, or regional wastewater. And the next are the responsible consuming. Being the responsible consumer, it is also the major combatant in the water pollution control. Personally, we are accepting the responsibility to dispose of the chemicals properly instead of pouring into the sewage drains. Generally, don't add this certain waste material in this water body. So the approach to determine water pollution control, the three main approaches are there. The main approach to determine problem this water pollution, water ecosystem. It is in the three-step process: identification of pollutant, sources of the pollutant, and effects of this pollutant here on the life. The type of the pollutant, the first step in this approach to water pollution control, determine what kind of the pollutants are responsible for the water pollution. So agriculture runoff, the fertilizer pollutant is there. Then second, another part is there. Here natural pollutant, displacement, earthquake, and industrial runoff, that are chemicals. Then what was the source of the pollutant? It is second step in this approach. So how the pollutant comes? Manufacturing plant, wastewater piping, and natural disaster, that the disaster. And after that, after turning some source of pollutant, then what was the effect of the pollutant? These effects determine whether the water is still safe to drink or not, or whether it is killing the wildlife, or whether it causes the algal bloom, or whether it has its discolored water. So for this same, so being this after studying certain approaches, then certain water pollution control methods are to be used. The habitat conservation, energy conservation, water conservation. So these are the methods which are, these are the ways you can use in the water pollution control. So these and as well as the use of the BOD in the pollution control mechanism. Here the another parameter you can use in the water pollution control. So besides the same water pollution control, here then the regulation limits for the disposal of wastewater in the here. So what is the regulation limits in the same wastewater or treatment center wastewater? And these regulation limits depends on here disposal land, disposal river, and also disposal wastewater. Here disposal land, again three methods are there: irrigation, rapid infiltration, and also the overland flow. And inclusion of the ocean, disposal in the ocean. So this disposal in ocean, it may be accomplished by the submarine outfall that consists of long suction pipe to transport the waste from the treatment plant to the shore. At the each fall, here outfall treatment and untreated waste is released into the stream. At this point, the waste is mixed with the surrounding water body, the surrounding sea water, and rises to the surface water where it dips. Here, such rising is there. So this method is called here advection. This dipping mix the wastewater properly, and maximum micro oxidation is occurred, and it helps in the water pollution control in the here. in case of this wastewater disposal in the ocean. There is a disposal in the sea water as well as river water. They are also very significant in the water pollution control. So by this way, here such all the points, all these here, units are there. In the fourth unit, bioaugmentation, the alternate methods. Second, industrial wastewater treatment, the specific industries. Third, the wastewater, waste disposal control and regulation, the water pollution control and the disposal of the wastewater in the lake, rivers, and ocean, and also the land. So this is all about this syllabus of this paper number 3, paper number 402, industrial waste management. And so to discuss about some paper, some references are also there. And these references, the most common references, usually environmental biotechnology, the industrial pollution management by S.N. Joglan and S.N. Joglan. So this book is very good book where in this book here you can get this the topic, the microbiology and biochemical wastewater treatment. So all these points are here clear in this same book. As well as the another book is also there, the water and water pollution and book, that the Leonard L. CSU. So this book, in that the two books are there, volume 1, volume 2. And in that book here, the first topic is totally here, totally there. The first, the type of the characteristics of industrial waste and the effects of industrial waste in this in the same book. But the third topic, self-purification of natural water bodies. Yeah, introduction, physical processes, chemical processes. So this topic, it is in this separate book, the microbial ecology by Lynch. So such another book, a very good book is there. The next book, there is a common book, Wastewater Treatment by M.N. Rao and Datta. As well as another book is there here, the Water Pollution Microbiology by Mitchell. Then Environmental Microbiology by P.D. Sharma. And another, this book is not listed in this list or in the reference list, Microbial Ecology by Atlas and Batra. And Water Pollution by Cause, Effects and Control by P.K. Goel. So all these books are available in our library. All these books are very good books. So these books you have to refer that, and then these academic books here you can discuss this topic or this paper to the students. Lastly, here I am very much thankful to our management, our management, and also this General Secretary of this Shivaji Shikshan Sanstha, Board for Education Karat, Honorable Prakash Babu Patil. Then I am also very much thankful to all the members of this education society, as well as I will also very much thankful to our principal, Dr. S.P. Kengar, who has very good organized this workshop. As well as I am also very much thankful to all the members of organizing committee, then all the team to handle this in the same workshop. As well as I am also very much thankful to all these participants to participate in this workshop. As well as also I am very thankful to non-teaching staff who cooperate with this same workshop and make this workshop very successful. And finally, I am also very thankful to all of this here which are involved in this same workshop. Thank you once again. Have a nice day.
Thank you, Sawan sir. So the topic industrial waste management, it is open for discussion. So if anybody is having any kind of doubt, feel free to ask. My voice is audible or not? Okay. So we will continue for the session day 2. But before that, we have to take a break of 5 to 10 minutes. Please continue the link of Zoom. It's my request to all participants. Keep your audios switch off, but stay linked with us. So we are taking break of 5 to 10 minutes.
नाही सांगितलं. आम्हाला गुड्डे वगैरे सगळं म्हटलं आपण बोललो. मज्जाच झाली असते. एकदा कधीतरी काहीतरी काय झालेलं कोणाच पेपरच अडकून बसलेला अडकत माहिती आहे कसं काढायचं. परत अडकलं की मला सांग, काढून मोडून दे. करू म्हणला हे सरांना सांगितले पाहिजे बरं का, कागद आणून आणि तिथले पूर्ण संपले टाकू. लगाने का पडेगा पाणी गरम
हा सर, पण आवाज येत नाहीये सर अजून तुमचा. हॅलो सर, आवाज येत नाहीये.
हॅलो,
हा येतो येतो. लहान येतो.
रिक्वेस्ट करायचं.
ओके. सर आवाज लहान येतो तुमचा.
हॅलो, आला का?
हा येतो, जवळ घेतल्यानंतर येतो.
येस येस.
So shall we start now?
Yes, I'm ready.
All participants are requested to join us again because we are starting with the next session. Okay, let us start. So to the next, it's time to welcome our second speaker, Mr. Tawfiq Ahmed Tambedkar, who is a research scientist M1 Pharma Injectable Microbiology at Lupin Research Park, Pune. His educational qualification is MSc Microbiology, Postgraduate Diploma in Production and Operation Management at IGNOU University, New Delhi. As per his for 3 years as a QC microbiologist, work as a senior executive at QC department of Lupin, Goa for 6 years, and working now as a manager and research scientist at Lupin Research Park, Pune. He has worked on a lot of core experimental microbiology like validation of microbial instruments, raw materials, study of microbial recovery of swabs, then dilution study of various injectable products, determination of efficacy of UV lamp, microbial analysis of on sterile products, bacterial endotoxin test of injectable products, water analysis, bioassays, environmental monitoring, disinfectant efficacy test, chemical analysis of injectable products, and many lot of work he has done onto the various areas. So today he is with us to explain us about new practicals or practical course 6 unit 1. So we are continuing with the session number 9 directly with Mr. Tawfiq Tambekar. May I request him to continue for the next session, Mr.
Thank you,
Tawfiq
ma'am.
Tambekar, sir. Yes. I can
Good
hear
afternoon,
you.
all of you. Respected teachers and all other members, myself Tawfiq Tambedkar, working as a research scientist at LRP Pune. And today we are going to touch a little bit part of important aspects that we are dealing in pharma industries in daily life. Okay. So many of us, while many of us don't know what actually work is going on in pharmaceutical industries, and today I'm just going to touch some parts which are displayed on your screen. First one, that is calibration of weighing balance. Second one is calibration of thermometer. Third one is culture dilution study. Fourth one is, that is more important thing, that is disinfectant preparation and its validation before using it in microbiology laboratory. Then validation, that contains design qualification, installation qualification, operational qualification, and performance qualification of autoclave, that is the heart of microbiology. Then incubators and refrigerators. Then the next point is handling of incubators, pH meters, and oven. And last one is the media preparation. So first we will start with calibration of weighing balance. Many of us don't know what is the difference between the calibration and validation. So let me clear one thing, is that calibration is the process that ensures that accuracy is maintained in the measurement produced by your instruments, or calibration ensures that the instrument or measuring device produces accurate results before using it for microbial analysis. And second part is validation. Validation is a documented process that provides assurance that a product, service, or system consistently provide results within the acceptable criteria. Or validation provides documented evidence that a process, equipment, method, or a system provide consistent results as per our acceptance criteria, or it ensures the uniform batches are produced. Many of us Also consider that what is the difference between qualifications and validations. Qualification is related with the equipment and validation is related to the process or a system. For example, if you want to do validate of a system like water system, we need to do validations. And if you want to qualify an instrument, in that term, we will use qualification for the instruments or equipments. Okay. The next part is weighing balance. The balance is used to measure the mass of analyte with high degree of precision and accuracy. So if we see any deviation or inaccuracy in the weighing balance, that would impact in our analysis. So weighing balance should perform its accuracy, that is very mandatory process. So first part is test weights. The test weights needs to be of high accuracy, but essential that its mass remains constant. Okay. The second one is operating range. Each weighing balance should be of a proper range, which is mentioned before procuring it. This is permitted weighing range, which is defined by minimum and a maximum value according to its range. Then the action limit, it is the process or tolerance as per USP, United States Pharmacopoeia, and termed as control limit, GWP documents. It requires accuracy of weighing application. If this limit is exceeded, then immediate action must be taken. Okay. Then warning limit. This limit is smaller than action limit by a suitable factor, namely safety factor. So the warning limit is obtained by dividing the action limit by safety factors, that is 2. This gives sufficient time for corrective action. So if you want to see what is the actual performance of the weighing balance, so we need to perform different tests while checking its accuracy and performance. So there are different tests which we carry out in our daily life, like the daily calibrations and repeatability test, then linearity test and eccentricity. So in daily calibration, what we do, we need to perform daily prior to use of the balance, which measures minimum and maximum weight measurements within the acceptance criteria. For example, if my balance is of 200 gram of capacity, maximum capacity, and minimum capacity is of 10 gram, then what we do for daily calibration, we use the standard weights to check the balance is performing its activity properly. So we take the weight of 10 gram within the acceptable criteria, and the maximum weight is of 200 grams. So we take the weight of 200 grams. And in the daily calibration, the reports get generated and it is prepared by the user and reviewed by the expert or the reviewer. Okay. Similarly, there are different other tests which are required to check the performance of the balance, like repeatability test to verify the intended process uncertainty of the balance. Same weight. This repeatability test we perform in different time intervals, like monthly or quarterly or 6 monthly, depending upon your procedures. It might vary. Okay. To verify the intended process uncertainty of the balances, same weight. For example, if we take a weight of 100 gram, we take the same weight for 10 times to check the standard deviation, whether the performance of the balance is doing it properly or not. If we see the variations in the same weight, then it might impact on the final results, which could fail this particular test. Okay. In linearity test, this test is to be performed to check the linearity and sensitivity of the balance under the criteria of accuracy to challenge the systematic deviation individually. In this test, it measures all the weight. For example, the proper range of this balance is from 10 gram to 200 gram. Then we measure all the weights. For example, 10 gram, 20 gram, 50 gram, 100 gram. We check the acceptance criteria of all the weights which is displaying by the balance is accurate within the acceptance criteria of which is mentioned or which is mentioned in USP. Okay, this is about linearity test. Then eccentricity test. This test is designed to check how the balance displays its value is influenced by position of the test weights. For example, this weight is measured at 5 varying positions. For example, if we are having a pan of rectangular size on which we are going to measure our products. So what we do, for example, if we take 100 gram of weight is there, we keep it at different locations, for example, at center and 4 other corners, and we check there is any variation in all the positions. If the balance is showing variation, that we measure in the terms of deviation, standard deviation. there is specific formula mentioned for the same. The next point is calibration of thermometers. As we know, thermometer is playing very important role in all the fields to check the temperature of media as well as other parameters in chemical as well as microbiological analysis. So it is a device. We will see something related to calibration of thermometers. It is a device that measures temperature or temperature gradient using variety of different principles. A thermometer has a temperature sensor in which physical changes occurs with the temperature, and this physical change is converted into numerical value. There are different types of thermometers which we see in our daily life, like glass thermometer, thermohygrometers, which measures relative humidity as well as temperatures, etc. Here it is mentioned inspect the UUC. UUC is nothing but unit under calibration to which we are going to calibrate and compare it with the standards. Standard means which is already calibrated and which should be used as a standard to compare the results with the thermometer which is under calibration. Okay. So first of all, while doing calibration of thermometers, what we need to do, inspect the UUC physically for any breakage or deterioration, because if there is any breakage in the glass, then it would might impact on the final results. That's why we need to take prior precautions that we need to inspect for any breakage or deteriorations. Then allow calibration standard and UUC to stabilize with conditions. For example, for the same conditions at the normal room temperature or anything like that. Ensure both the calibration standard and UUC are inserted in the temperature source minimum up to their immersion length. Okay. Capture the reading of UUC with that of calibration standard. Means what we need to do, we need to capture the readings of both the thermometers, like the thermometer which is under calibration as well as the thermometer which is considered as standard. Okay, there is one table which is displayed over here. You can see the acceptance criteria which is mentioned is plus minus 1 degree Celsius between the UVC as well as the standard thermometer. Okay, here you can see the details which are mentioned here are the calibration standard details, which is already been calibrated and which can be used as a reference standard for the UUC. Okay, in the observation section you can see we have captured many calibration points depending upon the usage of the thermometer. For example, minus 30 degrees Celsius. Okay, in that what we need to do, we need to immerse the both the thermometers in the minus 30 degrees Celsius of water, and we need to check the difference between the master reading as well as UUC reading. The master reading is nothing but the standard temperature readings. Okay, here we can see the comparison between the UUC and master reading observed is UUC shows 29.8 degrees Celsius. Similarly, the master reading is showing minus 29.9 degrees Celsius. Means the deviation is 0.1 degree Celsius, which is acceptable. Our accuracy should be plus minus 1 degree Celsius. Similarly, there are different points are covered here, like 0 degrees Celsius, 25 degrees Celsius, 50 degrees Celsius, 75 degrees Celsius, and 100 degrees Celsius. Depending upon all the calibration points, if we can see, there is not too much differentiation or deviation between master reading and as well as the UVC reading. Okay, it means that this is acceptable range and we can use it for normal calibration, normal usage process, as well as the calibration can be defined on the basis of your usage. Like you can perform it on 6 monthly basis or yearly basis. Okay, we shall go to the next slide. That is culture dilution study. As we all aware of culture dilution study, but still I need to focus on some other points which are going on in pharmaceutical industries. First of all, what we need to do, the preparation of challenge inoculums, in which prepare an 18 to 24 hours of old broth culture of individual standard bacterial test organisms, which are mentioned below, separately in SCDB at 32 to 35 degrees Celsius, like E. coli, Pseudomonas S. Pseudomonas aeruginosa, Bacillus subtilis, and Salmonella aboni. Okay. Similarly, for grow separately Candida albicans and Aspergillus niger, as they are eastern molds, at they require 20 to 25 degrees Celsius in SCDB for 2 to 3 days. After that, what we do, dilution of all the cultures using BSCP, that is nothing but buffer sodium chloride peptone solution, which is having pH of 7. Whether you can prepare it in microbiology lab or you can procure directly from high media or any other source. to make the test suspensions contains less than 100 organisms per ml by preparing 10-fold serial dilutions up to the 10⁻⁻10. Okay. Using the pour plate technique, plates in the duplicate the final 5 dilutions using appropriate culture, such as soybean casein digest agar for bacterial cultures and soybean digest dextrose agar for fungal cultures. Allow to solidify, invert the Petri plate and incubate to 30 to 35 degrees Celsius for 3 days for bacterial culture, and similarly 20 to 25 degrees Celsius for 3 to 5 days for yeast and mold cultures. As yeast and fungal cultures take maximum period for its growth, so it will be incubation period is more for fungal and yeast cultures, that is 3 to 5 days. In some of the SOPs, it is mentioned that it might require 5 to 7 days also. Okay, that is also acceptable. After completion of this process, note down the number of colonies in case of Aspergillus niger on 3rd day of incubation, because after 3rd day of incubation, it might give spreaded growth, which is difficult to count the colonies. So select the dilution which gives the less than 100 CFU per ml, because in pharmaceutical industries, for checking of media quality, we need to perform the test called as growth promotion test, in which we require to spread the colonies up to 100 CFU per ml of the dilution of each and every organism to check the recovery rate of these organisms on the particular media, to check the quality of the media, which is provided by or prepared by the in-house microbiology lab. And the next is the table which is mentioned here to prepare the dilutions of the stock cultures, in which the blank spaces which is mentioned over here is, for example, if you want to prepare the culture dilutions, the serial dilutions are mentioned over here. For example, if you want to use 1 ml of the in the blank section, we can add 1 ml of the stock solution in 10 ml of BSCP containing pH 10 of pH 7. Okay, accordingly for this will be the 10⁻⁻1 dilution. And similarly, we need to prepare the dilutions further by adding 1 ml to 10 ml of solution A to B, then B to C, accordingly up to 10⁻⁻10 dilutions. In the next section, it is mentioned that we plate out the final 5 dilutions, because in which we take the counted colonies. Otherwise, if we plate out the dilution A or B or C, there that will give you the spreaded growth, which is not useful for our intended purpose. Okay, so here we mentions the load number of the particular required, which is required to incubate in the inverted positions. Okay, and the load number which is mentioned here is on which we are going to perform the culture dilutions, and the incubator number, then incubated by and incubation completed by. Okay, and the final results can be recorded in the next table, that is colony forming units, that is plate 1 and plate 2, which we are going to do it in the duplicate to get the assurity of the results. And the mean, the number of organisms in the CFU per ml in the stock cultures is also going to be mentioned over here. Okay, shall we go to the next slide? This is the important factor before procuring any disinfectant in the pharmaceutical industry. We need to check the different aspects. For example, which we are going to see it in the further session. Disinfectant preparation and validation. Before using of any disinfectant in microbiology laboratory, we need to check the different aspects like spectrum, contact time, as well as compatibility of the surfaces, mode of action, any poisonous activity, or like it would impact on the health, different parameters which we need to check. For example, that's why I'm going to show you one example of Virex 2256, which we have validated in our lab and which have shown proper results. Okay, so aim is that to determine and validate the bactericidal and fungicidal efficacy of broad spectrum environment cleaner and disinfectant Virex 2256. Okay, to perform this study, the media and material which is required are as follows: SCDA media, SCA media, de-English neutralizing broth, that is nothing but the neutralizing broth which used to neutralize the disinfectants of particular concentrations which are going to use here. Then buffer sodium chloride solution for washing purpose, then sterile 0.45 micron cellulose filters and blood serum, then glass test tubes, Petri plates, test tubes, 1 into 1 square inch of coupon, for example SS304, glass, vinyl plastics, acrylic, epoxy, painted surface. If you want to ask me why these surfaces are used here, because these are the normal surfaces which we come in contact with in the lab, or while performing the testing of the products. These are the surfaces which normally come in contact with our testing purposes. Like SS is the stainless steel, then glass. For example, if we are using biosafety cabinets, we are having glasses over there. Then epoxy surfaces, these are compulsory in pharmaceutical industry for the floors. Then painted surfaces like on the walls. And then next one is the disinfectant solution, which is prepared in potable water because we need to check the efficacy of the particular disinfectant. We are not preparing it in purified water because we need to check the efficacy. Okay. Then the microorganisms. The microorganisms which we are going to expose or challenge it with the disinfectants like E. coli, S. aureus, Pseudomonas, Bacillus subtilis, Candida albicans, and Aspergillus brasiliensis. Now the procedure. In the procedure, the disinfectant virus 256 shall be compared with other available disinfectant against the following criteria to select the proper disinfectant for our intended purpose. Then the parameters which we consider here for the selection of the disinfectants are spectrum of activity, means how it impact on the organisms, like if it impact directly on only bacteria or fungi, or it impact on both the categories. Okay. And second one is the contact time. The contact time is nothing but the contact time which is coming disinfectant come in contact with the surfaces, which is effective to kill the organisms by log reductions. That will come in second part. Then compatibility of with the surfaces of the disinfectant. Then mode of action. Then safety consideration, if we are using a particular disinfectant which might harm or which might be poisonous, which can cause impact on our health, that should be also taken into consideration. Then disinfectant rotation. It means that we can't use the same disinfectant in continuous manner for whole month. So in that way, if we are using a virus 256 for 1 week, then definitely we are going to use the second disinfectant like Savlon or Bacillocid, like that is disinfectant to get to check or to confirm that the organisms might get resistant to this same disinfectant by using it again and again. So we use it in the rotations. Okay. The next slide. Prepare appropriate serial dilutions, plate out the cultures, determining the count per ml, like we have performed the culture dilutions over here. Dilute with the BSCP to obtain final working suspension 10:5 to 10:6 cells per ml. That is culture dilution study. Can we go to the next slide, Jaising? Okay. Then here the point is disinfectant preparation. Prepare the disinfectant solution as described below. For example, if you want to prepare the 0.4% of Virex 256, then add 4 ml of disinfectant to 996 ml of potable water and mix it well. Or add 1 ml of disinfectant to 990 ml of potable water, that is 0.1% Virex to 256, and mix it well. Why we are using these two disinfectant? Because we need to check which concentration is impactful to kill the microorganisms. Then we are deciding the contact times, that is 5 ml, 10 ml, 5 minutes, 10 minutes, and 15 minutes, which is more impactful, that we are going to check. In this category, disinfectant challenge testing using dilution study. Dispense 10 ml of disinfectant prepared in label sterile tubes assigned for contact time interval of respective solutions for all culture solutions as specified in the table. Here you can see the contact time table and neutralization, in which what we do for 5 minutes, 10 ml of disinfectant plus specific culture. For example, if we are adding culture like E. coli that contains 10⁵ to 10⁶ CFU per ml, which we are adding to disinfectant, and we are keeping it for 5 minutes. Okay. After 5 minutes, what we are going to do, add 10 ml of neutralizer in each tube after the allotted time. That neutralizer with that is DENB. That DENB will neutralize the disinfectant to kill the microorganisms. On the basis of that 5 minutes, we are going to do further procedure, that is use the sterile pipette and inoculum of the appropriate culture dilution of 10⁵ to 6 cells of each standard organism, and environment isolates. If we are having environment isolates, for example, environment isolates are nothing but what we do in manufacturing areas. We perform the environment monitoring, and we get some colonies in environment monitoring in manufacturing sites. So these isolates we we perform the culture dilution of these isolates and we separate it. And these isolates can also be used to check the disinfectant efficacy test. Okay. Here what we do, in each tube time interval, add 10 ml of neutralizing medium broth and mix well. Filter the entire content of the each tube on 0.45 micron of membrane filters, and wash the filter for 3 consecutive successful 30 ml of portion of BACP solution. Okay. Place each filter on the respective agar and incubate at specified temperature and period of mentioned below, that is SCDA for 30 to 35 degrees Celsius for 72 hours, and SCA for fungal culture, that is 20 to 25 degrees Celsius for 5 days. Similarly, the same procedure needs to be performed for 10 minutes and 15 minutes of exposure to cultures by the disinfectant and neutralize it accordingly. And in what we have mentioned here is positive control. In positive control, what we do, we add 10 ml of sterile water and 1 ml of culture, which contains 10 to 5 to 6 cells CFU per ml. And then what we do, we add neutralizer of 10 ml. Okay. What we check here, we are not adding here disinfectant to check that. We are not adding here disinfectant because we are not going to kill the organisms. We need to check that that organisms or cultures are okay there, and they are giving our proper recovery after plating it out. So we are comparing in the positive control. If we get the proper colonies, we are comparing the log reductions in final results, means which time point is effective and which concentration is effective in that. In the negative control, we are not going to use culture here because we are going to check whether the sterile water or neutralizer we are going to use here, they are free from organisms, they are not having any contamination. So that we need to check here, because if there is any contamination in the sterile water or neutralizer, then definitely they are going to impact, or they are going to highlight it in our testing purpose. That will impact to our final results to calculate the final log reductions. That is more important thing. Okay. So shall we go to the next slide? Jason? Okay. Next point is neutralizer efficacy test. In neutralizer efficacy test, that is we are going to take the whether the neutralizer which we are using here, that is D and B, is going to cause any harmful impact on the cultures, or whether it would impact to growth inhibition of these particular organisms which are going to use in this study. Okay. So to check that neutralizer efficacy test, we are going to perform a separate test here, that is dispense 10 ml of disinfectant solution, each prepared in 15 sterile tubes. Why 15 sterile tubes? Because we perform the study using 15 different isolates, means different cultures. That's why 15. According to, if you want to perform different few organisms, then we can use, for example, if you use 5 organisms, then we can use 5 sterile test tubes. Okay. Add 10 ml of neutralizer to each of the tubes bottles containing disinfectant. A microbial culture suspension of all standard microorganisms and environment isolates shall be added, such that per ml of content contains not more than 100 CFU. It means that we are not going to add here 10⁵ to 10⁶ cells. Here we are going to add only 100 CFU or each culture isolate differently. Okay, in which we are going to check that particular neutralizer is going to impact on this organism or not. Okay, then filter 1 ml of the content of each of the microorganism through 0.45 micron membrane filter and wash the filter with 3 successive 30 ml of portion of BACP. Why we are using the BACP to wash here? Because while performing the membrane filtration method, while performing this method, when we use the membrane, while we pour the cultures, what happens? It might stuck to the edges of the filtration cup. That's why we need to wash the sides of the cup to get the stuck organisms to the membrane filters, to get it absorbed, and then we get then only we can get the proper results. Okay, place each filter on the surface of the respective agar plates, means for bacteria that is SCDA and for fungal culture that is SCA, and incubate the plate at specified temperature and period for each plate as mentioned below, that is incubate the filter with bacterial culture on SCDA at 30 to 35 degrees Celsius for 72 hours and fungal culture from SCA at 20 to 25 degrees Celsius for 5 days. Similarly, for positive control, what we need to do, 10 ml of sterile filter purified water in test tubes and add 10 ml of neutralizer to each of the sterile test tube, and a microbial culture suspension of standard organism and environment isolates shall be added, such that per ml of content contains not more than 100 CFU. It means that we are going to check here what is the actual point is going to come, or we are going to observe in positive control, that we are going to compare it with the test solution. Okay. Similarly, we are going to perform the next procedure, that the membrane filtration method, and depending on SCDA and SCA plates. Simultaneously, we need to perform the negative control test in which we are not going to add any kind of cultures here. We are going to check the sterility or the proper quality of the purified water which are going to use here, and as well as the neutralizer. Okay, in which take 10 ml of purified water in the sterile test tube and add 10 ml of neutralizer to it. Filter 1 ml of the content through the 0.45 micron membrane filter, and wash the filter and with the 3 successive 30 ml portion of the BSCP. Same procedure which we have followed for positive control as well as for the test solution, and place the filters on SCDA and SCA and incubate it at 30 to 35 degrees Celsius for 72 hours and 20 to 25 degrees Celsius for 5 days. That is for fungal culture. This is all about, we need to check about the neutralizer efficacy test. Means neutralizer means the neutralizer which we are going to use in this study, the efficacy of this neutralizer, whether it is going to impact or harm the organisms which are going to use in this study. This is the criteria of this particular test which we have performed here. Okay. So next point is surface challenge test. This is the actual test we are going to use it to define whether the disinfectant is okay or not. Okay. In this surface challenge test, what we do, we are going to expose the organisms and disinfectant to the cultures which were mentioned earlier, like SS, stainless steels, epoxy surfaces, then painted surfaces, glass material, etc. Then here what we need to perform is, we need to prepare the test coupons of around 1 into 1 inch square of each material, like stainless steel, glass, plastic vinyl, acrylic, epoxy, painted surface, etc. Sterilize the coupons using autoclave. That is depending upon your autoclave qualification, which autoclave cycle you are qualified it for qualifying the glasswares. Okay. In case of heat sensitive material, dip the material coupon in absolute alcohol, that is 100%, aseptically. Hold the sterilized coupon in sterile glass plate linked with the filter paper to create a sterile environment. This is the important step. In case of disinfectant, for challenge, 20 microliter of culture or the spore suspension along with 5% of blood serum in the applied surface to the coupon surface, spread evenly over 1 square inch area and dried it for 30 to 40 minutes at 37 degrees Celsius. It means that what we do here, we sprayed the cultures, like all the cultures which we are going to test here. We have sprayed the cultures on each surface with the 5% of blood serum to confirm that whether the cultures are not going to kill. Okay. After that, we spread it evenly on the surfaces and we dry it in the 37 degrees Celsius in the sterile environment. It means that we keep the all the surfaces in the sterile Petri plates and get incubated in the 37 degrees Celsius to get it dry for 30 minutes. After that, this test coupon will be used for the test. The disinfectant prepared as per SOP is applied on the using a duster saturated with the disinfectant, or by spraying the disinfectant solution on the coupons by simulating actual cleaning operations. It means that we are going to spread the disinfectant solution by using the spray on these cultures after this process, and we are going to keep it on the contact time. Okay, the contact time which we have decided earlier in the previous study. Okay, the contact time and the concentration of this disinfectant. After that, after respect to time intervals, means the contact time which we decided earlier to check the log reductions, the tested coupons assigned for each interval is aseptically transferred to 100 ml of neutralizing media. It means that we are going to transfer these test coupon aseptically to the 100 ml of neutralizing broth. So it means that we are going to stop the activity at that moment only. For example, if we are going, if our validated our concluded time is of 10 minutes, then we are going to expose that cultures to the disinfectant solution of these surfaces for 10 minutes only. After 10 minutes of timing, we are going to expose or transfer it to 100 ml of neutralizing media. It means that we are going to stop the activity at that point only. Then these coupons are agitated with the glass beads to remove the surviving organisms which are placed or attached on these culture on these surfaces. The extract is a membrane filter through a 0.45 membrane filter. Wash the filter with again 3 successive 30 ml portion of BSCP. Then place the cultures filters on respective plates, for example, bacteria on SCDA and fungal on SCA. Then quantify the bioburden of each individual coupon by membrane filtration method. Okay, similarly or simultaneously, we are going to perform positive control as well as the negative control. In positive control, definitely we are not going to use disinfectant over here, because we are going to check the cultures efficacy which are going to grow, and we are going to compare it with the test solution. That's why we are growing here actual concentration of the organisms. And similarly, in negative control, we are not going to use cultures here, because what we need to see here, we are going to check the efficacy or the sterility or quality of disinfectant solution as well as the neutralizing media which we have used here. Okay, the same procedure we need to follow for positive control as well as for the negative control. After performing or after completion of these incubation plates, observe incubation period, observe the plates for the colonies if any, and record the results. Here what we are going to check, the log reduction in the concentration of the microorganisms. So the acceptance criteria which we need to define prior to approval of this protocol is what we are going to achieve in this study. Okay, according to that, the dilution and the concentration of the disinfectant process. For example, the dilution means the concentration. For example, what we have prepared is 0.1% of virus or 0.4% of virus is going to be effective to kill to achieve our final results. And the contact time which we have studied, that is 5 minutes or 10 minutes or 15 minutes. Okay, in which what we need to achieve is the dilution in the contact time of the for disinfection process for using a particular disinfectant shall be one which gives more than 3 log reduction of the CFU compared to the initial count of the bacteria. The initial count is nothing but the positive control. What we need to see in positive control, for example, if we have achieved 10⁶ or cells CFUs per ml, and if we are going to check the test solution, if we get 10⁵ cells, it means that we have observed 3 log reduction, which is acceptable for us, because here the disinfectant is going to kill the organisms by 3 log reduction, for example, for bacteria, in case of bacteria. And for spores and fungi, if we the dilution in the contact time for a disinfection process of using a particular disinfectant shall be one which gives more than 2 log reduction in CFU compared to initial count for spores and the fungi. The time of exposure which gives more than 3 log reduction at a given concentration of vegetative cells is considered to be a valid time for exposure. The dilution of concentration which gives more than 3 log reduction is termed as valid concentration. This is what we are going to check here. And the study which we have additionally carried out, that is neutralizer efficacy, in which the count of the, here we have exposed only 100 organisms over here in test as well as in positive control and negative control. For example, if we get proper recovery of 100 organisms in positive control, and in negative control there shall be no any growth. And similarly, if you get 80 organisms in test, it means that it giving 80% of the efficacy of the neutralizer. It means that it gives our proper recovery, and that neutralizer is not going to impact on the organism's growth. That we are going to prove here. The next parameter is validation of autoclave. As we all know that autoclave is a, shall we go to the next slide? Okay. An autoclave is a pressure chamber that is used to sterilize the media, accessories, etc., and decontamination of the media, glasswares, and cultures. The sterilization process eliminates, remove, or kill the microorganisms or deactivate all from the lives and other biological agents. Here, if you can see, there are different kinds of autoclave are available in pharma industries, like horizontal autoclaves and vertical autoclaves, depending upon their capacities, like 180 liters to up to 1,000 liters, and depending upon the requirements of the products. So here we can see prior to use or of the autoclave, we need to validate its parameters, and after that only we can use it for the intended purposes. So the important aspect we are going to see here is how we are going to validate the particular autoclave, refrigerator, or incubator. So validation is a documented evidence which provides a high degree of assurance that the specific process or equipment will consistently produce or results meeting its predefined specifications of quality attributes. There are different phases of the validations. For example, when we want to procure an autoclave, what we need to see here user requirement specifications. we need to prepare the user requirement specifications. It means that a list of specifications or requirements of the buyer require that equipment to be purchased. It is sent to equipment manufacturer to make its intended purpose, like space, capacity, make, utilities, operational requirements, power supply, circuit, diagrams, part list, warranty certificates, etc. After that, what we need to check is design qualification. It defines the functional and operational specification as per URS are meeting the specification at our site. Means after receipt of this particular autoclave at our site, we are going to check its operational and functional parameters, specifications on the basis of the documentation. Okay. After that, after approving of these documents, we are going to further step, that is operational qualification. It defines or demonstrates that equipment functions according to its operational specification in selected environment. It means that in operational qualification, for example, we are going to take an empty chamber cycle by placing the sensors, and we are going to check whether the autoclave is performing its activity as per the intended criteria. Here we are going to calibrate the safety gauges, the pressure gauges, as well as the temperature sensors which are installed in that autoclave, and whether they are performing its activity as per their intended criteria. After passing all the results, only we can proceed for the performance qualification, which is the final step. Okay. In the performance qualification, we demonstrate that the equipment consistently performs according to specific appropriate to its routine intended use. Yeah, similarly, in operational qualification, what we have taken is the only one cycle of empty chambers. Here we are going to take 3 cycles of each and every parameter, like empty chambers, heat penetration cycles, and all those things. Okay. Then actually we come to the performance qualification. Here we can see only the DQ, IQ, OQ parameters are same for all the qualification instruments. We will see the performance qualification is different for all the incubators and refrigerators and autoclave. So we will see one by one. That is performance qualification of the autoclave. In the autoclave, the performance of the autoclave shall be tested for 3 cycles of empty chamber, 3 cycles of media cycles, sterilization, 3 discard cycles, that is nothing but the decontamination of the plates as well as cultures, 3 glassware cycles at set temperature of 121 degrees Celsius. That might be 121 to 124 degrees Celsius of bandwidth. Sterilization hold, depending upon your developmental cycle, that might be 20 minutes, 15 minutes, or 25 minutes, or 30 minutes. For decontamination, according to BMW guidelines, it has mentioned that for before transferring to ETP plant, we need to decontaminate the plates and the cultures up to minimum 60 minutes. Okay, at 15 psi to 17 psi. Okay. Here we are going to expose or check the quality of the cycles by exposing it with the chemical as well as biological indicators, which might comes in glass ampoules, disc wires, SS wires, etc. They are thermophilic organisms which are resistant to different sterilization processes like geobacillus stereothermophilus, and which is commonly used as a biological indicator to check the qualification of or performance qualification of the autoclave. Here I have mentioned or highlighted a diagram in which it shows how we are going to calibrate or how we are going to place the sensors in the autoclave while performing the temperature mapping or data or cycle data. Okay, sensors shall be located as per the location diagram as below. Here we can see that in the black spot it is mentioned that these internal sensors are already being present in the autoclave. Okay, and the sensors which you have placed, like by the external, this is going to be performed by external party which we are hiring to perform the PQ. Okay, so here there are 2 containers which we can see here. In the upper container we have installed 4 sensors, and in the next container we have installed 4 sensors. It means that we are covering all the chambers to check the temperature integrity or temperature uniformity of the chamber, which it means that on the basis of that we are going to define the hot spot as well as the cold spot in the particular chamber of the autoclave. Okay, the next page. The different cycles which we are going to perform here is empty heat chamber cycle. Here we are not going to keep any material in the chamber. We are directly installing the 8 sensors of data logger in the chamber as per the respective diagram, and ensuring that the end of the temperature sensors do not come in contact with the walls of the chamber, because it might impact on the temperature which we are displaying out on digital data loggers. Okay. This temperature determines the, here in empty chamber cycle, which only we are going to check uniformity of the chamber. It means that the temperature which are here, after increasing the temperature at 121 degrees Celsius, each and every corner of the chamber is going to attain the temperature that we are going to check here. Okay. And place the chemical indicator strips at the same location as that of the temperature sensors of the digital data loggers in each of the sterilization cycle. It means that these chemical indicators are nothing but the parameters or the indicators which shows that after achieving the 121 degrees Celsius of temperature in the chamber, these indicators are going to change their color. On the basis of that, we can conclude that the temperature inside the autoclave is achieved to our intended temperature, okay, for 20 minutes and pressure of 15 to 17 psi. Observe the chemical indicators at the end of the cycle for color change. Acquire the data from the data loggers and repeat the exercise for 2 empty chamber cycles. Okay, this is about the empty chamber cycle. Next, that is heat distribution and penetration cycle. Here, we are going to use porous as well as non-porous material, and we are going to load here medias as well as glasswares as well as decontaminated material and cultures, etc. Okay, this we are going to say take separate cycles. Here, what we can do is arrange 8 of the sensors of the data logger in the chamber as per the respective diagrams which are designed for each and every cycle, ensuring that the end of the temperature cycle do not come in contact with the glassware or the walls of the chamber. Okay, place the indicator strips at the same locations as that of the temperature sensors of the digital loggers and in each of the sterilization cycle. Place the biological indicator ampoules. It means that we are going to keep here biological indicator as well as chemical indicators that we have not kept in empty chamber cycles. Okay, why? Because here we are going to expose media cycles, glasswares as well as decontaminated polybags. Okay, here we are going to check these biological indicators are nothing but the precise number of organisms in the glass ampoules which are resistant to the specific sterilization processes of 121 degrees Celsius. After reaching it to particular temperature only, they are going to kill. Okay, these are the spores of Geobacillus stereothermophilus organism 80cc7953, which is a standard organism which is used to check the performance of the autoclave. This test determines the consistency of autoclave in performing the specified cycle and challenges the media load, discard load, and glassware or accessory load by verifying the bioindicator and chemical indicators. Heat distribution and penetration cycle should be carried out at set temperature of 121 degrees Celsius for 20 minutes of media cycle, glasswares and accessory cycles, and for discard cycle that is 60 minutes. That is the BMW guideline is recommending us to perform the decontamination cycle for at least 60 minutes. Here only there are different parameters are going to come here in the cycles. We are going to validate the cycles depending upon the loads. For example, if we are going to take a media cycle, it means that we are going to validate in minimum as well as the maximum loads. We are going to take 3 cycles of minimum load. We are going to take 3 cycles of the maximum load. It means that we are defining a range of minimum as well as maximum load in the particular cycle parameters. And then only we are going to use it for routine purposes, that we cannot go out of the maximum loading pattern, or we cannot use or sterilize the media capacity more than that validated pattern. Okay, that we are going to define here. Now the final is that acceptance criteria. This is to be defined or this is to be approved prior to the performance of this activity. Performance qualification shall be considered acceptable when throughout sterilization whole time the sterilization temperature at each of the sensors should be within the band width of 121 to 124 degrees Celsius. That is the lower limit and upper limit. Quantity of the sensors of all cycles should be 8 numbers. Here, why we have used 8 sensors? Because our capacity of autoclave is not too much. That's why we have used 8 number of sensors. Depending upon your capacity of the autoclave, you can shift to 8 sensors or 18 sensors. Okay, that is also mentioned in HTM guidelines. Okay, then what we need to check, chemical indicator strip placed at each locations within the chamber of the autoclave should show uniform change in color at end of the cycle. It means that after completion of the cycle, it should be changed as per their acceptance criteria. It means that it should turn equal or darker in color than reference arrow. Okay, there is one arrow which is mentioned over here that I can't show you right now. that is initially that is white in color, but after exposure of these indicators to specific sterilization process, these arrows get changes to darker in black in color, which defines that the autoclave cycle has performed perfectly. Similarly, if we check the biological indicators, we placed at each location within the chamber of the autoclave should not show any growth. It means that we are going to incubate those ampules at specified temperature of 55 to 60 degrees Celsius for 48 hours, and we are simultaneously incubating the positive control as well as the negative control. In positive control, we are using the ampule which is not exposed to sterilization temperature. It means that, for example, if it comes in blue color, after exposing it, the positive control which is used here, that is going to be a change in color after going of this organism at a specified temperature of 55 degrees Celsius. That is going to change in yellowish color, which shows that positive control means that unexposed organisms are going to grow. And the ampules which we have withdrawn from the autoclave after sterilization temperature, they have not shown any growth, means they are not turned into yellow color. It means that all the organisms which are present in that ampule, that is of 10⁶ ampules per glass vial, that has been destroyed or killed by the sterilization temperature. It means that sterility assurance level of these autoclave cycle is achieved. Means one organism is also not survived out of 10⁶ cells. It means that one organism also not survived in 1 million. It means that our cycle is achieved as per our intended criteria. That is the parameter which we have checked here. Here, the purple color remains purple. Unexposed, that is negative control, which comes differently in that pack, in which there is no any organisms, only the media which is used for the cultures, that is only there in the negative control. Okay. And then finally, the oil cycle should require F0 value is more than 15 minutes. F0 value is nothing but the parameter which gives you that the time in minutes, or the time in minutes required to kill the microorganisms at D value at 121 degrees Celsius of Z value of 10 degrees Celsius, difference of 10 degrees Celsius. It means that if you go in detail in autoclave validation, there are different parameters comes under discussion, that is like D value, Z value, then F value, then F0 values, SAL values. There are different values which we are not going to discuss here. That is very deep. Deep discussion that will require much time. So we are going to touch a little bit of F0 value. We can see F0 value is nothing but the number of minutes which are required to kill the microorganisms. Okay. Then performance qualification of incubator. In performance qualification, check the calibration of status of the temperature data logger with sensors to be used for performance qualification. Ensure that temperature data loggers with the sensors to be used for validation is calibrated. It means that this temperature loggers should be considered as standard prior to performing the performance qualification of the incubator. Here you can see the diagram. This is the inside surfaces or inside view of the incubator. There are the racks on which we are going to keep the media plates as well as the media pass after the testing. Okay. Place 7 sensor of the temperature sensor as shown in the diagram. As per the temperature sensor location diagram, channel 7 is in the air. As you can see, channel 7 is placed outside the incubator, which you can see outside the incubator, which is used to check whether the temperature of the room temperature is within the acceptance criteria. It means that our requirement is that the temperature should be mentioned below 25 degrees Celsius, and humidity should be maintained below 60 60%. Then how we are going to perform the activity? Connect the temperature sensors to the data logger, start the data logger and verify the correctness of the clock timer with actual time. Also check the display of the temperature in the temperature channels of the data logger. Set required recording intervals in the data loggers that you can set according to your approved protocol, 5 minutes, 10 minutes or per minute. Okay. Place one temperature sensor near the incubator controlling sensor, one sensor to record ambient room temperature, that is outside, and the balance 5 number of temperature sensors to be placed in such a way that to represent it geometrically. It means that whole chamber we are going to capture over here. The next slide. After temperature gets stabilized, note down validation start time. Note down the validation start time that we are going to perform it for 24 hours of print interval time of 5 minutes to complete the qualification study. That is MD condition. You can take the cycles for validated pattern. You can take it by maximum loaded pattern also. Then what we do here, we check the door open and close study. It means that we have procured the incubators which are required to be perform their activity in the alertness. It means that they are programmed, and online temperature monitoring is going on, which are installed with the specific software which is given by the vendor, in which we check door open and close study. Means if you open the door for more than 2 minutes or 5 minutes, if the temperature goes out of limit, it means that if our set temperature is 25 degrees Celsius and our window is 20 to 25 degrees Celsius, if the temperature goes out of 25 degrees Celsius, means 25.1, then automatically that incubator is going to give you alarm, which it means that you need to close the door as soon as possible to remove the plates as well as or to complete your task which is related to your incubator. Okay. Their power on off study means that if your incubator is get off by any power failure or anything, that footer is going to give us alarm, which is separately monitored or installed to check the activity of the incubator, because very critical activities are going on. Means very valuable products which we are analyzing or consuming for analysis. If the temperature goes out of limit, it means that the incidents might happen and which might cause loss to the company. That's why these activities are installed to monitor that incubators are performing its activity properly. Okay. Then incubator temperature mapping is performed for 72 hours at a print interval of 5 minutes to complete qualification study. That is the loaded conditions. Details of load will be given by the customer. Depending on our requirement, we define the loaded patterns in our incubator qualification. On the basis of that, we perform the activity. Then last part is acceptance criteria. That is the distribution of the temperature in the chamber shall be given within the range of plus minus 1 degree Celsius of the preset value. Preset value is nothing but the middle point of the 20 to 25 degrees Celsius. Okay. If our range is 20 to 25 degrees Celsius, then our middle point is 22.5 degrees Celsius. Okay. So the set temperature is 22.5 degrees Celsius. So the acceptance criteria is 23.5 to 21.5 degrees Celsius. So the data logger, the data which is which we have taken from the data loggers, it should show the range plus minus 1 degree Celsius of the preset value. Similarly, the refrigerator procedure is also same. The performance in here is to be performed by temperature data mapping using the data loggers for 24 hours only. The next point is handling of incubators. These are the SOP. Basically, this is the SOP which we monitor here. Preliminary check. Check and ensure the equipment is clean and free from the dust externally and internally. Daily. Okay. Then basic operation. Switch on the main switch on the control panel. Set the temperature to value as specified for respective incubators. Means there are different incubators which are set at different set temperatures, like you can see in the table: 43 degrees Celsius, 32.5, and 22.5. That we know 22.5 is for fungi and yeast, 32.5 is for bacteria, and 43 is for McConkey's broth, which we are going to use for test for E. coli. That is required for enrichment method of E. coli, when we inoculate the E. coli organism in McConkey's broth for 20 to 48 hours at 43 degrees Celsius. And the acceptance criteria is mentioned here: 40 to 45, 30 to 35, and 20 to 25. Okay. So the setting is done by pressing up or down keys, as I have shown here, of the temperature controller. On the basis of that, we can adjust the temperature of the incubator. Here, additionally, one more incubator we procure here for which is qualified for all these temperatures. And if any of the incubator shows breakdown, then we can shift all the testing material which is incubated in particular incubator to that standby incubator to avoid hampering of the activity or incubation. Okay. The set value is the set, shows the set temperature, and another value displayed on the screen is actual temperature inside the incubator. Okay. The calibration is nothing but the digital display unit are to be calibrated once in a year by external agencies under service contract. Okay. Then recording. Manual monitoring of the incubator's temperature is to be done for evaluation purpose twice every working day. If the software is not installed in the incubators, then we need to perform the activity twice a day or thrice a day to check whether the temperature is within the acceptance criteria. Okay, so that are the manual monitoring. Or if there is a software, we can download directly from the software the records of 24 hours. From last 24 hours means, for example, from 9 o'clock of previous day to 9 o'clock of present day. Okay. The section head or his designee, his or her designee shall review the data against the acceptance criteria and sign against the head reviewed by. Means the user or the analyst is going to perform the activity or record down the activity, and same is going to check or reviewed by the section head, okay, or the manager. If the temperature going out of limit for more than 1 hour in the absence of the personnel in the laboratory, it means that in the night, if the temperature goes out of limit, then impact of the departure in the temperature data on the test samples material shall be evaluated according to the incidence procedure, and incidence shall be raised. Okay. The next part is handling of pH meter. Precautions. Instrument should be free of dust before using pH meter. Ensure the calibration is done, because pH meter calibration and balance calibrations to be done daily prior to use. Okay. Don't dip the whole electrode in the solution. It should be around 3 in deep, and instrument should be kept on anti-vibrant flat surfaces to avoid fluctuations in the readings. Okay. In case of any air bubble formed inside the electrode, give it a firm shake to remove it, because these are very sensitive electrodes which might cause which might give you false readings. Okay, to avoid that, we don't need any bubbles. Okay, that pH meter is directly attached to the software, so we are not going to perform any activity or take the prints manually. Directly it is attached to the PCs or the laptops. When we check any pH of the particular solution of the injectable solution, that directly if we start, that reading is going to be captured by the laptops or these which is already installed the particular software of this pH meter, for example Horiba softwares or BioWare softwares. That is the online activity. Here we are not going to use any manual monitoring or any pen. That is going to be done automatically. Okay. Change the solution inside the electron on weekly basis. For example, there are different set points involved here for pH meter calibration. It might be 4-point calibration or 5-point calibration. Different electrode solutions of the buffers where we are going to use it for calibration. For example, 1.68, 4.00, 7.00, 10.01, and 12.45. Depending upon the requirement of your testing, you can calibrate the pH meter, and you can determine the slope which is required to 90 to 105%. That is the acceptance criteria. Okay. Then while calibration, wash the pH electrode with purified water and wipe it off by filter paper or tissue paper. It means that while doing the same, we can't use the rough paper to avoid the scratches on the electrode, which is very sensitive surface. Okay. Immerse the pH electrode in the beaker or the container of the standard solution, that are the buffers. Tap to start calibration with first point. Then after completion of this activity, we can go for subsequent stages like second point, that is 4, then 7, then 10 accordingly. Calibration should be performed daily, as I mentioned. pH measurement procedure. Wash the pH electrode with purified water and wipe it off by filter paper or the tissue paper. Immerse the pH electrode in sample solution deeper than around 3 centimeters from the tip, and start the measurement. That is all about pH meter. Then last one is handling of oven, basic operation. Normally oven which we use for the glasswares. After washing of the glasswares, we use it for drying at 60 degrees Celsius for 10 minutes. That what we require to check whether there are any traces which are inside of the glassware that might not impact in the further testing. So the basic operation is switch on the main switch on the control panel. The digital temperature display will indicate the temperature value. Set the desired temperature, for example 60 degrees Celsius, by using temperature setting knob. Then cleaning shall be performed after device cool down and after disconnection from the mains. Clean the inner and outer wall of the chamber with the water or respectively suitable chemical means. Calibration. Digital display units are to be calibrated like incubator, as we have discussed earlier, in a year by external agencies using under service contract. Now the final point is media preparation. As we all know, while performing the practicals, we prepare the media, but the procedure is a little bit different from in the pharma industries. The procedure for media preparation, that for each and every activity which we are going to monitor or we are going to record, that which media is consumed for which purposes and what we have done out of if we have received a bottle of 500 gram, after receiving it, there are different methods of checking the quality of the media. Media should be prepared in a proper way by adjusting the proper pH required for growth of the microorganism. Solid media and liquid media. For any culture media, solid or liquid, take properly clean glass apparatus, conical flask, bottles, tubes, etc. of different volume as per requirement. Where required quantity of the media mentioned on the label of the container reconstituted with purified water, and mention media labels. Okay. On the test tubes, flask, bottles, and enter the details in the media preparation record. There are different media preparation records in which at what time you are going to use the media, prepare the media, and who is preparing it, what type of media you are preparing, the lot numbers of the particular media, and prior to preparation of the media, already you have performed the growth promotion test, growth inhibition test, pre-incubation quality check. After performing the activity, you are going to use the media for routine analysis. Okay. In this, reconstitute the purified water and mention media labels. Okay. Heat the media on the hot plate to dissolve it completely. For example, if you are going to prepare SCDA media in the bottles, that is solid media, we are going to digest the media after adding it into purified water, and we are going to dissolve it completely. After that, cool to the room temperature, then adjust the pH. The pH might be 7.1 to 7.50. We have to adjust the pH and specified on the label, and plug the flask with non-absorbent cotton or cover with the aluminum foil or the stoppers. Okay. Sterilize or boil to the heat the media as per instruction given on the pack by the manufacturer. For example, if some constituents in the media are heat labile, so for example, there are different medias like Rapaport, Bacillidase, enrichment broth, which we use for enrichment of the Salmonella boni. That media is very sensitive to the sterilization process, so we perform the activity at 100 degrees, 150 degrees Celsius. Okay, so in that way, accordingly, we mention all the instructions related to the particular media in our standard operating procedures for the easiness. Sterilize or boil the heat of the media as per the instruction. For agar, cool the media to 40 to 45 degrees Celsius. For the sterilized media, means depending upon the requirement or sterilized patterns or validated pattern of their autoclave, you are going to sterilize it for 20 minutes or 25 minutes. That is as per standard procedure. Cool the media at 25 degrees Celsius at room temperature for solidification. After solidification of the media, check the pH of the solid and agar media. Place the media plates or test tubes in the 30 to 35 degrees Celsius for 18 to 24 hours. It means that we are going to check the pre-incubation test, that whether the plates which are incubated are grown any organisms or growth, to check its quality, to check the media for any growth. Testing of media. pH for each quantity of the nutrient media which is prepared in one run, take a sample after autoclaving and let cool it to the room temperature and measure the pH of the media. And media should be 0.2. Media should be between 0.2 from the initial pH. Okay, media should be within the appropriate range which is mentioned by the vendor in the COS. Okay, if the pH does not meet the acceptance criteria, the media must not be used and is to be discarded, because as we know, temperature as well as pH is the very important influential characters on the organism, so it might be considered as more important. If you get a media, if you receive a media which is not complying with the acceptance criteria for the growth promotion test, growth incubation test, and for example in pH it is not accepted, from that moment only we reject the media and we send it back to the vendors because it is not complying as per our requirements. Here, before pre-incubation of the culture media, label the media plate, name and lot number on the plates as per our standard procedure, then incubate the media to 24 hours in the incubator. After pre-incubation of the media, store the media at room temperature and visually inspect the media for any contamination. If we receive any contamination in the media plate, then we thoroughly investigate whether it is a human error or because of actual media which we have received from the vendor. And after that, if we come to conclude that if the media is actually having its problem, then we reject the media. We discard the media or return back to the that vendor. Okay, that is a familiar introduction with important aspects in the microbiology field in the pharma industry. This is all about my presentation, and thank you all of you. If you have any question, you can ask.
Thank you, Tawfiq.
Thank you, sir. Thank you, sir. Hi, sir. Hello.
You recognize me?
Yes, sir. Yes, sir. How are you,
Thank you
sir?
very much for this detailed talk that you have given.
My
I'm
pleasure.
sure the listeners have got a proper idea of what exactly has to be taught to the students.
Yes, sir. Yes, sir. Because what we have performed in college
Yes.
life is totally different from in the pharma
Yes,
industry.
exactly, exactly.
So that will be more helpful for next students.
Yeah. I have no questions. I just wanted to appreciate your talk. Anybody, any of the listeners have a question? Now they can go ahead. Madam,
you.
please coordinate the activity.
Thank you, sir.
I will stop now. Okay.
Yes, sir. Thank you. Thank you, sir.
Thank you, Mr. Tofik. So topic is open for discussion. Okay. We are grateful to have you as our second speaker today, sir, as you have a versatile experience of 10 plus years in a field of pharmaceuticals. Your presentation found to be full of knowledge of practical microbiology. Once again, thanks a lot for sharing your valuable time with us. Thank you, sir.
Thank you, all of you.
Now, it's our privilege to have with us Dr. S.S. Bajekar, sir, as our third speaker, who is a former Emeritus Biodiversity Fellow of Maharashtra State Biodiversity Board and former principal of Yashwantara Chavan College of Science, Karad. So it's our golden opportunity to hear Dr. Bajekar sir again for session number 7 of recombinant DNA technology. Now, it's my humble request to you, sir. Please gratify all of us with your words. Thank you.
मी ते बघत होतो दिसलं नाही मला. Thank you, Yadav madam, for again introducing me to the audience. It is again my privilege and honor to be here with all of you to tell you. Today I'm going to talk on, as you can see in the very first slide, recombinant DNA technology. Now, before I start this talk, I would just like to mention a little bit about the syllabus and things like that, not just our syllabus. Shivaji University students need not apply. That used to be a refrain or a last sentence in every job advertisement when I joined this college as a lecturer. Because in those days, Shivaji University was new. It was established in 1962. And as you know, it was established in Kolhapur and this region. Students from this region, mainly coming from a rural background, used to experience considerable difficulties with the English language and things like that. So even after they pass out and went for jobs in Pune and Mumbai, people used to look down upon the students and thinking that they are not knowledgeable, they do not have any knowledge. I'm telling you, when I used to read these sentences on the advertisements, I used to be shocked. I used to think, why are they thinking like this? But before me, even before I could think about anything, there were stalwarts in our university, in the various university departments and including principals of colleges, of which the principal of our college here was a pioneer in that, Principal Shri R.M. Raverkar. He was a visionary. And that time the stalwarts recognized what was the major problem and how to overcome it. So they realized that even if the English language is a bit of a handicap for our students, we have to make it up in some way to see that they get enough jobs. And for that, one of the strategies they used, or rather two strategies which they adopted, was firstly, the syllabi. And mind you, I'm talking of the entire university, all the branches, all the subjects. And microbiology as prime, because microbiology was a new subject which was pioneered in our college. That is why I mentioned our erstwhile principal in this. So they took a decision that there are two strategies that we have to adopt. One is contemporary syllabi. Every time some new concept in science or any other field came up, they would become aware of that. They would include those subtopics in the syllabi and make them contemporary, up to date. And that practice has been continued so long, even today. The topic which you just heard from Mr. Tawfiq Tambedkar before me, that topic has also been introduced into this syllabus in this particular revision, I think. And I'm so happy about it, because this topic is a very later, I mean, you can say a very essential topic for our students who take up jobs in industries. So this is a very useful topic. So you see what I mean. The topics are always contemporary. And the second aspect that they decided was that the syllabus in every college and the departments has to be taught 100% in as much detail as possible. And that was a strategy, that was a mission for all of us teachers when we joined in this college, and we have practiced that right from the beginning. Complete the syllabus fully. 100% completion of syllabus is the goal of all teachers. As a result, what has happened is the knowledge base of our students has gone up tremendously. They are very much knowledgeable. And mind you, once some person gets the knowledge about some aspect, some subject, the confidence level of that student or that individual also goes up sky high. And that is what has happened with our students from our university. And today, the tables have been completely turned. Not only are students of Shivaji University welcomed for jobs, slowly, I'm sure they may start writing in their job advertisements also, only Shivaji University students need apply. If that stage comes, I will be the happiest man, let me tell you. So in this context, in our subject of microbiology also, my predecessors and even the current people are involved in the microbiology, you people are doing a great job. Whenever syllabus revision comes up, you incorporate all the latest topics in that, and the syllabus is made up to date. And when you do the teaching fully 100%, let me tell you, it is my experience that the students get so much of detailed knowledge about the subject that even if they do have a handicap of English, which is also become redundant nowadays, let me tell you, wherever our students go, they are welcomed with very warmly, with broad arms, with an embrace. They welcome us. They said, come and do the jobs for us. And that is why you see Tawfiq Tambedkar, who just gave you a talk now. He is one of those students that I am talking of. And the remaining following lectures after mine that you're going to listen are also of our ex-students who are doing extremely well in their fields of application. So that is a little bit of introduction I would like to give. Now coming to my topic, recombinant DNA technology. This also is a current topic, as you all know, and this topic was also included in our syllabus some time back. In the 3 or 4 revisions earlier, it had been introduced. And you can see this technology being a current technology. This is also discussed in full detail. Now, I'll be going through this paper a little rapidly because the syllabus of this top paper has been defined so thoroughly. When you see the 4 units that are included here, the syllabus has been divided very well, because this is a technology with which our students need to be conversant. Unfortunately, at college levels, many a times to conduct all the practicals that are, because this paper also, like yesterday's biostatistics and all that which I discussed, this is also a tool for advancement of biotechnology. So this being a tool, students need to be fully conversant with the topics, with all the techniques that are available here. And therefore this paper attempts to give just that. So the syllabus, as you can see, there are 4 units. The first unit describes gives you information about all the tools that are required for this technology, because when you want to operate any technology, you need the proper tools that are to be used there, the techniques that are required. And the first unit of this syllabus, as you will notice, gives you details about all the tools used. And being a molecular biological technology, all the molecules that are involved, and all those have been given in the first unit. Then the second unit describes the basics of recombinant technology, which, as we microbiologists know, has evolved and has been developed in E. coli. E. coli, which is known as the fairy godmother of microbiology. You are all familiar with it because E. coli is a microbiologist's best friend. E. coli gives us so much. That's why we use E. coli. So the basic technology of cloning that has been developed in E. coli, as you are all familiar with. And then that technology was adopted or adapted to eukaryotic organisms. So in the third unit, you will find the topics discussing the eukaryotic cloning techniques, all the unicellular eukaryotic cells like the yeast and fungi, and then you go on to the higher organisms like animals, plants. All those techniques, whatever techniques of cloning are used in those organisms, have been discussed in unit 3. And finally, in unit 4, you have the applications of rDNA technology, which are the more important, the actual result, which today is in a very, very large extent, right? So I'm just going to go quite briefly on this paper, just discuss some of the salient features, what you teachers need to tell the students, how much of detail you need to describe, and so on. So firstly, definition of recombinant DNA technology, which is also for short known as rDNA technology, as you are familiar. This is the definition that I've given. It is actually joining, mind you, I have specifically used this word by artificial means, because joining of DNA is basically a natural phenomenon that happens in nature routinely, whether there is asexual reproduction or sexual reproduction. Joining of DNA does happen naturally itself. But here, recombinant DNA technology, meaning it is an artificial means. And that is why I've used this word, this phrase very specifically, by artificial means, which means we human beings carry this out in the laboratory, as you know, in vitro, as we call it. So from two different species, insertion into a host organism to produce new genetic combinations that are valuable to science, medicine, agriculture, and industry, different fields where it is applied. So you just need to give this definition. As you all know, this is also known as genetic engineering, and the actual process of joining the DNA molecules is known as cloning also, because when you insert it into a new organism, in that organism you get a clone. Clone is a replica. So replica of the parents is found in the progeny, and in this case it is at the molecular level. So a new organism is developed by just fusing of some of the genetic material. Now before that, a little bit of history of recombinant DNA technology, how it came about. I've given you in the slide, there are 5 important landmarks. Werner Arbor, who discovered restriction enzymes; Hamilton Smith, who discovered the type 2 restriction enzymes, which are the most commonly used tools in recombinant DNA technology. Then Daniel Nathans was the first one to apply restriction enzymes to a scientific study. He studied the map of the SV40 virus, as you know, simian virus 40. He studied the genetic map using these enzymes. And then Paul Berg attached DNA to plasmids. That was the first instance of attaching or joining DNA to another DNA, and that is the plasmid DNA. And finally, Stanley Cohen and Herbert Boyer, they carried out the first actual transformation into E. coli, or cloning into E. coli. Of course, further development, the credit is given to Maniatis. But Maniatis was the one who actually standardized, you can say, or he prepared the general protocol, a detailed, thorough protocol for the cloning or genetic engineering technology. And therefore, he is also given a lot of credit, which we'll talk about. You see in the syllabus there, the strategies that we have discussed. So here I again talk about the tools. You need to describe these tools in quite a bit of detail. That is given in the first unit. As you will see in the first unit of the syllabus, you have the enzymes, you have the linkers and adapters. Linkers and adapters are DNA molecules, simple small DNA molecules, which are used to link to larger DNA molecules which are not compatible with each other. means they do not have sticky ends maybe by which they will join with each other naturally. So for such molecules, you need these special kinds of DNA molecules which are constructed called linkages and adapters. Then you talk of cloning vectors, which includes plasmids, viruses, virus-based vectors, other kinds of cloning vectors. Now these all describe the tools that are used for prokaryotic rDNA technology, mind you, because as you will see in topic number 2, you will see the vectors that are used for eukaryotes. So all those details you have to teach here. You have to tell the students the details of these enzymes, because mind you, these are the basic tools of rDNA technology, and students need to have thorough knowledge about these. The knowledge about these are available in any of these genetics books, and also mostly in microbial genetic books and genetic engineering books that are available. They are given in the list of the references at the end of this syllabus, or rather this paper, as you know. So you can refer to any of them. I think the first book in the list is by Principles of Genetic Engineering or rDNA Technology by Primrose and Twyman. That is a wonderful book. It gives you the details of all the topics that are there in this syllabus. In fact, I would go so far as to say that this particular syllabus here has been designed keeping that book as a model, using that as a model. All the topics are given. But besides these main tools, that is the enzymes and other nucleic acid molecules and so on, and the vectors, many other tools are also tools I have written, but they are techniques which are also required, mind you. This technology is not as simple as just putting something in the machine and at the end of the machine assembly line you will get a product. It's not like that. All this is done in the laboratory, and in the laboratory which other tools or techniques are required, I've given a list of all that. In microbiological techniques are also very important here. Please note dilution and plating. We talk of streak plate technique, then spread plate technique. Spreading is used here, dilution and spreading, because you're all familiar with this. You need to get well isolated clones or colonies on the Petri plates so that replica plating can be done. Then you require centrifugation, electrophoresis, chromatography, PCR, radioisotope tracing, fluorescence labeling, ELISA. All these techniques are also required. This is just a small indicative list, mind you. As you teach the topic, you will come across the places where you will come across the names of some of these other techniques also. So these particular techniques, you need not describe in detail when you are teaching them. You can only mention these techniques, saying that using electrophoresis, you separate the DNA like this, and then that DNA is taken. The electrophoresis is mostly agarose gel electrophoresis, which is used. Chromatography also, TLC is used, or column chromatography is used. But you don't need to discuss the principles of these techniques and things like that, because there is a separate paper for this, as you all know, in MSc Part 1. So here you just have to mention these techniques. But please make it a point to mention these techniques. Do not forget these techniques when you are teaching the topics. But as at each stage, you will come to a stage where you will realize that this technique is used. So you make a mention when you are teaching the students, mention that this technique is used there. So they will get a clear-cut idea about how it is done. Because you are talking of a general topic. You talk about the principles and how it is done, the procedure, everything you mentioned. No doubt, you have to teach that. Because I just told you a little while back, complete teaching of the topics is essential for our students to get that much of knowledge. So during that time, whenever you come to a stage that this technique is used here, logically you will think, you will get an idea. Being teachers, I'm sure you will get this idea. When you come across that stage, please make sure to mention that technique that is used there. Don't neglect it, because students need to know this, because in future, mind you, all these techniques we may not be actually doing in practicals here. But when they go out and they are required to apply this, whatever they have studied here, they should know which technique is to be used at what stage. So that is very, very important. So you need to lay a stress on that, teaching about the topic or the techniques that are used there. Other techniques, non-microbiological and others like I've listed above. Then here coming to the basic process. This is from unit 2, where I told you it discusses the basic technique of rDNA technology application in prokaryotes, that is E. coli, which is the model organism that we use. So it involves 4 steps. All the 4 I have listed in this slide. Cutting of DNA, that is the first one. Cutting of DNA, which DNA? The gene that you want to transfer into E. coli, and the vector DNA, whether it's a plasmid, whether it's a virus. You need a DNA which is a vector, and on that you're mounting your gene or the target gene. So how to do that? How to obtain the genes? How to obtain the plasmids for the linking? All that is discussed in this particular step, and the techniques that are required there I have mentioned. Restriction endonucleases type 2 are the prime ones, because we know type 2 restriction endonucleases have very specific sites of action, and that is why they are used in the preparation of your DNA molecules. Other enzymes are also there which are required. Phosphatidases are there, phosphorylase is there. There are so many others which have all been given in unit 1. All those enzymes are used. Then here I have mentioned about the linkers and adapters which I mentioned earlier. You have a vector DNA which you require, reverse transcriptase for DNA which you have to obtain from messenger RNAs. There are many cases where direct DNA may not be available, but you will have messenger RNAs which are in fact even better, because messenger RNAs are very specific to the polypeptide chain that is going to be translated. So the messenger RNA, from that you can get the specific DNA for preparation. So there you need the reverse transcriptase enzyme. From where that enzyme is obtained, how it is used. There, the word in bracket that I've written for cDNA, cDNA means complementary DNA. It is not cyclic DNA, please. Many times there can be chances of confusion. It is not cyclic DNA, it is complementary DNA, because it has been produced from mRNA. And then you know the technique CRISPR, which is also there, which last year in 2020 or 21, the discoverers of this particular system have got the Nobel Prize, and it is a matter of great pride for ladies, I'm sure, because the Nobel Prize for chemistry, of course, was given to the scientists Charpentier and Doudna, the 2 ladies who won this Nobel Prize for this particular work. Actually, when their announcement I saw on TV, I knew I stay alone in Pune. There was nobody around me, but when I saw their names on the screen that they had won the Nobel Prize, I was so happy that 2 women have won this prize. I started clapping wildly, let me tell you. I was very happy. Although I knew nobody is watching me here, but I clapped wildly and I was very happy about it. Nevertheless, let me go further. Then the second step is insertion into the hosts. Once you mounted your DNA on the vector, then it has to be introduced into the host. Now here we are talking of E. coli, no doubt. In E. coli, you have the plasmid. There are different methods that are available, which all come under biological techniques. But in eukaryotic cells, you also have the physical and chemical techniques that are used, which you will be discussing in unit 3 actually. Then the third point, expression of the transformed DNA in the host cells. Now here, the second topic that I mentioned here, I've written it in red color here because I wanted to stress the importance of this topic. Mind you, when you transform a gene from another organism into E. coli, expression of that gene in E. coli is very, very important. Not only in E. coli, but also in other organisms. When Boyer and who were the 2 scientists I just mentioned, when they carried out the expression or transformation of DNA into E. coli, they experienced difficulties because these genes were not being expressed. Then everybody, Maniakis and all those scientists, started studying what are the reasons, and they found there are 8 reasons why the foreign DNA was not expressed in the host E. coli DNA. And that comes under this topic of this kind. It's a separate topic given in Primrose and Twyman in that book, Expression of Foreign DNA in Transformed Bacteria. These 8 points need to be studied and discussed thoroughly with the organisms, because E. coli or any other host cell is a foreign cell for the DNA. So for the DNA to be expressed there, the conditions inside the host cell have to be favorable. Now, when they are not favorable, along with your target DNA, you may have to introduce some other DNA molecules also, which will also get incorporated in the host DNA, and the specific enzymes that are required for that will also be synthesized. Only then the foreign DNA will get expressed in the host. And finally, the fourth topic, screening and isolation. When you obtain these screens, organisms, they are known as the library, because you introduce the genes into these bacterial cells, and every bacterial cell may have another different genes. Now, this collection of bacterial cells, the correct clones, they are known as a genome library or a genomic library, because they are a collection of these host cells or transformed cells from which you have to select your specified or your clone of the desired clone. So from this genomic library, when you obtain a DNA or when you obtain a host which has been transformed with cDNA, that library is called a cDNA or complementary DNA library. So from these clones, you have multiple clones here. From these clones, you have to isolate your desired clone. For that, there are several strategies that are given, and they are all found in Unit 2, as you'll see, as I've been discussing. That is where Maniatis was the pioneer for this. He was the one who devised the simplest screening technique for the desired clone. Then other scientists came up with slight modifications and all that, and so many strategies are available. They are all described very well in the book by Primrose and Twyman. You'll find all the details there. You need to study that topic thoroughly, properly understand it, and then teach, because the topic can be a little confusing or complex, mind you. Let me warn you at the outset. You need to study these strategies in proper detail, and you get the idea, the concept, how they have gone about it. That is where you will have to imagine which technique they have used, where they have used centrifugation, where they have used electrophoresis, where they have used PCR. You'll have to find out all that, and then you will be able to understand these topics, and then you can teach the students. Maniatis' strategy was the simplest, but after that, there are many others that have also been devised. And all these topics have been, the names have been given in the syllabus, as you will say. First one starts with the examples I have talked about, Maniatis' strategy. Then the techniques involve hybridization, PCR. In order to specify what topics need to be taught to the students, these syllabi have been detailed in so much of minuteness. Each of these methods have been mentioned here so that teachers do not miss out teaching these topics. Otherwise, normally if we had just said screening of gene libraries, what from that topic has to be taught to the students, no one would understand. That is why the syllabus has been marked like this. In my initial address a little bit, where I mentioned, if you remember, we have to teach the syllabus 100%. For that, this is a very good guideline. What exactly needs to be taught there? This has been mentioned. So you have to teach these topics in that much detail to the students, so then they will be able to understand properly, and then they will be able to use this knowledge in their future. So please make it a point to describe, understand these strategies properly, and teach the students accordingly. So these are some of the important topics that you definitely need to tell the students. Then I'm going to skip Unit 3, because there is nothing much to discuss from my point of view, because it is quite clear in the syllabus itself. All the topics, like I've told you, the detailed points have been given in the syllabus. So there is not too much for me to actually discuss there. I will only end up describing, and description is when by reading it, you will be able to understand. So I'm not going to do that. I'm going to skip over it and then go to the last unit, that is the applications of rDNA technology. Here also, I've specified what you teachers need to do when you're teaching this particular topic to the students. The first 4 topics that are listed there, you can directly just describe and discuss the example. Mind you, giving examples is very, very important. You have to give examples there. For example, in the very first one, production of useful molecules in bacteria. You know, today by rDNA technology, there are so many hormones and other drugs which we use that are manufactured by rDNA technology. As an example, the most common that I can describe is insulin. Insulin, which is used for diabetic patients, it is manufactured by rDNA cloned bacteria, E. coli. E. coli has been transformed with the insulin gene. Cultivating that E. coli strain, the insulin has been produced, and that is harvested, purified, and marketed in the market. Similarly, there are others, a hormone called erythropoietin that is also produced by bacteria. There are so many others. In plants and animals also, that is being targeted today, because plants and animals are also considered as factories. E. coli are single cell organisms, unicellular, whereas plants and animals are larger, multicellular, large organisms. So it is a accepted fact that such organisms may be useful in generating these products on a very large scale. And that has been attempted with some of the products, especially in cattle. There are many products that are obtained in the milk from milch animals. So like this, you have to find out the examples. You'll get these examples in any book on genetic engineering. Definitely you will get the example. Even Primrose and Twyman has described many examples in this. So you just need to go through that. Give these examples because these are very important from the students' knowledge point of view. They need to know that. Then improvement of agronomic traits in plants. Nowadays, conditions due to so many conditions that we are causing, global warming, then drought conditions, salinity of soil. There are so many such adverse conditions that are being developed. And in such conditions, most of the plants don't grow. So you need to develop plants which are resistant to these adverse conditions. And therefore, genetic engineering or rDNA technology, one of the most important objective is to improve agronomic traits in plants, crop plants mainly, salinity tolerance, arid soil tolerance, dry desiccation, tolerance to desiccation, tolerance to pesticides, where you have the classic or prime example of BT cotton. BT brinjal is also coming up, but again the government has banned the research into that altogether. But BT cotton is there, which is creating a revolution. Although now of late, there are some problems that have come up with that also, I believe. I'm not too sure. Please don't take my word for it and don't quote me for that. But nevertheless, these are some of the kinds of examples that you have to describe, you have to tell the students. Then study prevention and cure of diseases. That is also being done on a large scale. So far, diagnostic tools based on rDNA technology have come up. Yes, as we know presently, the one test that is being commonly used for COVID testing are RT-PCR. That is one of the examples of this which is being applied. And finally, we come to genetically modified foods, where there are several foods that have been modified genetically. BT brinjal I just quoted, but that is not being marketed. It's not being developed in our country at all. But in the Western, in USA, in Japan, and some other countries, they have even started marketing these genetically modified foods. So you have to quote the examples of this, give the students these examples, so in their knowledge, in their database, in the head there, in the hard disk, they will have these items of knowledge available for them in their future. And then for the last topic, of course, I've written there, discuss the principles, techniques, and examples. Because protein engineering is not just genetic engineering, it is an offshoot. It is an extension of genetic engineering. rDNA technology is only a part of protein engineering. Mind you, it is only a part. It is a tool used in protein engineering. So it is by itself not protein engineering. Protein engineering is more than just rDNA technology. There are many other aspects of that also. And this topic has also been described in many books in detail under separate headings. Protein engineering, it has been described. So you need to study this topic also. study the principles of protein engineering, where rDNA technology is used, how it is used, what exactly is done after that. After rDNA, what is used, how are proteins engineered. Protein engineering basically means modification of the proteins. How that is done, for what purpose it is done, and things like that you'll have to study and then give its applications also. So this particular topic you will need to discuss in a little more detail, discussing its principles, the tools that are used, the technology that is there, and finally its applications. So this is how you need to go about this syllabus. I mentioned the earlier part of my talk specifically on this particular paper, because in this paper you will see the detailed elaboration of the syllabus, which I told you was decided way back when the advertisement used to say Shivaji University students need not apply. That time those stalwarts in the university had decided that this is how our syllabus will be framed, giving the details of all the topics so that all the topics are taught. And then they had decided upon this practice that the syllabus has to be completed from the very first word to the last word. And that is what everybody in the university did over all these years. And like I said in the beginning, the tables have now been turned. In the advertisements, no such sentence appears that Shivaji University students need not apply. They don't say that. But in fact, it has now come to a stage where Shivaji University students are welcome. That is the kind of words that they should be using. It is still some time for that to come on the advertisements in print. But I will be very happy if that does come into prints, and we are all headed that way. And I'm sure all of you teachers will do the same thing, carry forward this tradition to see that the students of our university, and I am talking about microbiology students, so I'm sure all of you will strive for that. Our microbiology students are doing very, very well everywhere. Anywhere they go, they are doing it. Now, on an aside, just as a part of a little bit of my own thing, I would tell you, when we all know that Serum Institute of India is the primary manufacturer of the COVID vaccine in our country now. Covishield is being manufactured in that. In Pune, wherever all my neighbors, anybody who would interact with me, I would very proudly tell them that more than 40 students, at least 40 to 45 students, people working in Serum Institute are from our university and my college. I very proudly say that. And whenever I tell that to anybody, I see their eyes light up. They feel so happy. I feel even more proud. So I'm sure all of you will keep up this effort and strive to see that our students, especially of microbiology, do not fall behind anywhere. So please take care to see that the syllabi, not just this paper, mind you, all papers of microbiology in this syllabus that we have, please ensure that you teach the subject, that paper thoroughly, right up to the last detail. And you teach it for that you will need to study a lot, yes, and a teacher's job is supposed to be that. So I encourage all of you. I wish you all the best. And this is, I come to the end of my paper and also my session in this particular workshop. I wish all of you teachers all the very best to train your students in the best possible manner. I once again thank the organizers here of my college for kindly inviting me and asking me to talk on 2 papers, not just one. I'm lucky in that respect, I would say. So I thank them once again from the bottom of my heart, and I conclude my talk. Thank you very much.
Thank you, Bajekar sir. Topic is open for discussion.
Yes, anybody have any questions, please? Nobody, looks like.
Okay, sir.
It looks like everybody has understood what I am trying to say. And
Yes, sir.
I'm very happy, I'm very thankful if you have really understood. I normally used to tell in the class, if nobody asks any questions, it means either 2 things. Either all of you have understood everything, or none of you have understood anything. I only hope it's the former and not the latter. Thank you very much.
I owe special gratitude to you for your guidance. Once again, thanking you, sir, on behalf of the team. Now, moving to the next session, session number 10. Today we have with us Mr. Valmik Patil, Assistant Manager in Encube Ethical Private Limited, Mudcamp, Goa. He is going to hold on for New Practicals Unit 2. I request Mr. K. Sutar sir to introduce the resource person.
Good afternoon to all. I am here to introduce today's speaker, Honorable Mr. Valmik Subhash Patil. He has completed BSc in 2007 and completed the MSc in 2009. And from 2009 up to date, they have been worked in various industries. Right now, they have been working as an assistant manager in Encube Ethicals. And he has got the uh, he has got the many key skills, that is it connected to the microbial limit test, then another again, that is bacterial endotoxin test. Then he has also has got the expertise carry out the sterility testing, water validation, then carry out the water testing, then carry out the method validation, carry out the also validation of cleaning, then carry out the equipment qualification. He has got also expertise in case of attaining the market complaints and overcome to that particular problems. Even though they have got the expertise to study concept with the change control into the industry, also there's also has got the expertise in concern with the audit compliance. Then they also has got the expertise in the QMS implementation. This is all about the brief introduction concept with the Honorable Mr. Valmik Subhash Patil. Thank you very much.
Thank you, sir, for such a brief introduction. Now, we are handing over the session to Mr. Valmik Patil. Can you hear me, sir?
Hello.
Yes, sir.
Uh,
Start your video, please.
okay. Just a moment.
The session is starting within next 2 minutes. All the participants are requested to switch off their audios and videos except the next resource person. Our next speaker, he is going to discuss about the new practicals. As we had already seen, the practical course 4, Unit 1 has been discussed by Mr. Tofik Tambedkar, and Unit 2 will be discussed by Mr. Valmik Patil.
Hello.
Good afternoon, sir.
Good afternoon. Is my voice audible?
Yes, sir. Voice is audible. Please fix your camera.
Presently, it's a little bit difficult because during working hours, it will be difficult for me to fix the camera. So
Okay.
I would like
Doesn't matter.
to suggest that only audio will be okay, or video is required.
Actually, sir, we are going online on live on YouTube, so that will be better if you are sharing the videos. You are sharing screen with us.
No.
Give a second, sir.
Yeah.
हॅलो.
हॅलो.
हां, मोबाईल आहे तो ठेवू शकते का असं व्हिडिओ फक्त? कारण आपल्याला
जस्ट ट्राय
यूट्यूबला
करतो मी.
टेबलवर वगैरे ठेवा, वर्किंग करता तसं आणि एक्सप्लेनेशन चालू करा.
Just I will try. Let's see.
ओके.
Because there is no as such suitable stand. Is it okay?
But this position, yes,
Yes, yes,
position is
yes.
correct, sir.
Okay, fine. So shall we start?
Yes, of course.
Yes, sir.
Okay. So basically, before moving to point, so as a brief, so what we are going to see today, as per the syllabus, is chapter number 10, that is the basic requirement. Okay.
हॅलो, कॅमेरा ऑफ झाला.
Hello.
हां, हॅलो कॅमेरा.
Sir, you.
ओके
Yes.
ओके ओके. आता राहू द्या चालू तसंच.
Okay. So in this, mostly first the classification of the labs. In that, technical details will be scheduled later. Means whatever the guidelines are there, so that will be scheduled later. Okay. And regarding to the practical approach of for the MLT, PET, sterility, that we will discuss in details. Okay. Hello.
Yes, sir. Continue. Yes, sir. You can continue.
Okay. So in this position, I am not visible. Am I visible now?
No, sir. I think your video has been switched off.
Okay. Just one moment. Okay, so we'll start with first practical approach of MLT. Okay, so MLT is basically used in a pharmaceutical industry. As per the term is microbial limit test, and as per it is Indian pharmacopoeia, and as per a USP chapter, if the products are manufactured for US, as per a USP 111, chapter number 62 and 61. So it is termed as a microbial examination of non-sterile product. So in it, basically how it is, the basic principle behind it may be MLT, it may be preservative efficacy testing, or it may be sterility or BET. Except BET, we have to check whether there are organisms present in it or not. So MLT is basically applied for the non-sterile products which are tested. Non-sterile products like tablets, capsules, what we use day to day, and sterility used for the parenteral drugs, means which are directly injected, or which the products which comes in direct contact with blood. So for firstly in MLT, okay, so there are two techniques basically. So first is pour plate technique, and second is membrane filtration technique. So before moving to the basic procedure, means which method to use, before that we perform method validation. Method validation in a sense, in a single sentence, if you want to say, it will be that known amount of organisms are inoculated in the product, and we see whether with that organisms are recovered or not. So based on that, we choose the method, that is pour plate technique, or next is membrane filtration method. Okay, so we'll just first look for 4 plate method. Okay. So in this, what we do is we generally, if it is not mentioned in any pharmacopoeia or any requirement, we first take 10 gram of sample. Okay. 10 gram of sample is added in a diluent. So generally the diluent used is SCDM, that is a soybean casein digest medium. Okay, or any buffered sodium chloride peptone of pH 7.0. So next, from that, what we do is there are two subtests in it for MLT. So first subtest is total aerobic microbial count and total combined yeast and mold count. And second subtest is test for specified organisms. So in first subtest, that is for total aerobic microbial count and total combined yeast and mold count, what we do is whatever sample we have taken in the diluent, we do plating, means in duplicate. So we take 1 ml of the sample and we plate it in duplicate. So for total aerobic microbial count, we use sodium casein digest agar, and for next is total combined yeast and mold count, we use Sabrod dextrose agar. So after pouring the media, after solidification, the plates are again incubated for total aerobic microbial count. They are incubated at 30-35, and for total combined yeast and mold count, they are incubated at 20-25. So for the incubation period for aerobic count, it is 3 to 5 days, while for yeast and mold count, it is 5 to 7 days. So after completion of incubation, you have to check for the count and you have to record the result. Okay. Now for specified organism, depending upon the monograph, what we do is whatever the sample we have, just what we have earlier used, that is 10 gram in 90 ml of the diluent. From that same sample, we incubate that flask at 30-35 for 24 to 48 hours, depending on the organism. So basically, there are 4 organisms which are mainly tested. So in that it is E. coli, then Pseudomonas, Staphylococcus aureus, and Salmonella. So based on the category of the product, in that you can there might be different organisms. So example, for if the product contains water, it includes Burkholderia cepacia complex. So these additional organisms have been introduced. So what we have to do after completion of the incubation, then we have to streak it onto the selective plates. For E. coli, we use McConkey's agar. Then for Salmonella, we use XLDA. For Staph, we use MSA, that is menthol salt agar plate. For Pseudo, we use citramide agar. And for BCC complex, that is Burkholderia cepacia complex, we use Burkholderia cepacia complex agar plates. So after completion of streaking, we incubate the plates for minimum, for except for BCC, that is Burkholderia cepacia complex, the incubation period is minimum 48 hours, 48 to 72. For rest, it is 18 to 72 hours. So after completion of incubation, we check for the specific typical growth is present or not, and depending on that, further identification is done. Okay. So now in this main part, the reporting part is there. So for first part, that is part A, that is total combined yeast and mold count and total aerobic microbial count. In that, the formula we used is plating volume into dilution factor, count observed into dilution factor divided by plating volume. So in this, if you have count 0, so dilution factor, that is you have taken 10 gram of sample in 90 ml. So the dilution factor will be 10, because the reporting what we have to do is per gram. So for MLT, all the results what you have got as per the specification of pharmacopoeia, we have to report it in per gram. So the dilution factor will be 10 if you count 0 into 10 divided by volume. So volume we have used is 1 ml plating. So the answer should be 0, but while reporting, we report it as less than 10 CFU per gram. Okay, so this is the main thing what we have to understand is while reporting, if there is no count, we have to report it as less than the dilution factor. If you are using, there might be some samples where you use 10 gram in 990 ml of diluent. So in that, for reporting, the dilution factor will be 100. So in that, you have to report as less than 100 CFU per gram. So both for total aerobic microbial count and for total combined yeast and mold count. While for specified, depending on the specification or monograph chapters, you have to report it as absent or present per gram or per 10 gram. Usually for Salmonella, the requirement is reporting as absent or present per 10 gram. So this is for the MLT as per the 4-plate method. Now for membrane filtration method, what we have to do is you have to take 10 gram of sample, you have to add in the same diluent, and you have to filter it. So after filtration, you have to incubate. For in it also same. For example, there is a product in that only TMC and TYMC is there. That is total aerobic microbial count and total combined yeast and mold count. So 10 gram of sample you have to take. You have to add it in a diluent. After diluent, you have to filter 1 gram of sample. Means that is 10 ml you have to filter. So that will give you 1 gram of sample that you have filtered. Okay, you have to place that on a soybean casein digest agar media for total aerobic microbial count, and you have to incubate at 3 to 5 days. And for total combined yeast and mold count, you have to incubate. You have to place the filter on Sabrots dextrose agar, and you have to incubate at 20-25 for 5 to 7 days. So after incubation, you have to note down the results. Now in this, as you have taken directly 1 gram of sample, there is no dilution factor applied. So the reporting will be per gram. It may be 0 CFU per gram. Okay. Hello.
Yes, sir, we are listening.
Yeah. Okay. So this is basically for microbial limit test. Okay. So before moving to next test, I would like to ask if anyone is having query on it.
See, if any participant is having any query, you can ask to him. Or you can add it into the chat box also. I think nobody is having.
Okay, fine. So moving for the next test, that is sterility testing. Okay. So like MLT, the sterility has fluid thioglycolate medium and SCDM. Okay. So in this, mostly there are two types of techniques are there. That is closed method and open method. So in a closed method, we use canister. In it, the membrane filter is already placed in it, in the canister. So you need not to open the container. Okay. And in open method, what we have to do, we have to pass the sample to the filter, and we have to place that membrane filter into the medium. That is a soybean casein digest medium, and that is one. And second is fluid thioglycolate medium. Okay. Then after completion of the test, we have to incubate it for 7 or 14 days, depending on the requirement. And then further, you have to check for the presence of growth or not. So if growth is present, it means that your sample fails. If growth is absent, it means your sample passes. Waste, if there is a growth, you have to further do the identification of the organisms up to species level, and you have to conclude the investigation. So basically sterility is very simple, but the techniques or hands-on what we do, the activity we perform is very crucial. Now in this, before performing the sterility, we have to check the cleanliness of the area. Okay, the LF what we used, it has to be cleaned thoroughly. Then whatever samples we are going to use, okay, that also has to be sanitized from outside. Okay, there is a special means in any laboratory, if anyone wants to perform sterility testing, sterility testing area is a must, which is dedicated for sterility testing area for sterility testing of a product. Okay, so suppose we want to taste a sample for sterility. So depending on the sample container, there is a specific formula for how much sample containers are to be analyzed. It's not like MLT that 10 gram of sample we have to analyze. It depends on the number of containers what has to be analyzed. So from each container you have to pull the sample, okay, aseptically. Now whatever activity you will be performing, it will be performed under biosafety cabinet, and during performance of your activity you have to expose the plates, that is the environment monitoring plates, to check if your activity is performed correctly. Means how do you understand whether it is correct or not. So after completion of your activity we incubate the plates, and if there is a growth, then we understand that during handling there is a contamination. If there is no growth, we say that there is no growth, means you are handling aseptic technique is perfect. Okay, so once you pull the sample, you have to transfer it to the canister. Okay, in closed system there is a canister which contains media, also membrane filter, and in open system you have to put you have to pass the sample through the filter, and after completion you have to pour the media into it and you have to incubate. Okay, so after incubation, as I told, after 7 or 14 days you have to check for the results and you have to note them. Mostly the SCDM is used for aerobic organisms, and fluid thioglycol medium, it is used to check for the anaerobic organisms. Okay, all the relevant chapters, USP chapters, or British Pharmacopoeia, Japanese Pharmacopoeia, then Russian Pharmacopoeia, Indian Pharmacopoeia chapters, I will the reference related materials I will share you later. Okay, so this was a brief about sterility testing area. So if anyone is having query, we will discuss. Otherwise, we'll move to next test.
Anybody is having any query? So what is HTML?
Yes.
As last sentence you said.
Huh.
What is HTML?
HTML no. FTGM it is, fluid thioglycolate medium.
Okay, it's name of
FTGM.
Okay. Okay, sir. Continue for next.
Okay. So next important chapter we will. Hello.
Yes, sir.
Okay. So the next chapter it is based on the environment monitoring techniques. So in every organization in pharmaceutical industry, whether you produce non-sterile drugs or sterile drugs, we have to check for the area in which the products are manufactured is meeting the criteria of the regulatory requirement. So basically there are in manufacturing there are class like grade A, grade B, grade C, grade D, controlled area and uncontrolled area. So depending on the particle size and on the classifications are done. So if the details are given in ISO guideline plus as well as in USP chapter number 1116. So basically what is environment monitoring? So environment monitoring is done to check the microbial load, what is present in that particular area. Okay, so we'll take one example. Now at present, if you say any tablet manufacturing facility, that is we call it as a oral solid dose, that is OSD. So in that the mostly the area what is used for production manufacturing, it is class D, or we call it as ISO 8 area. So in that, what we do is for environment monitoring, there are basically two techniques what we use. That is, first we'll go for air monitoring. So in that, setter plate exposure, and second is air sampling technique. So setter plate is passive, and air sampling technique, it is active sampling technique. Okay, so we'll first look in what is setter plate technique. So what we do is we prepare media that is SCDA, that is soybean casein digest agar. Okay, if there are any antibiotic preparations carried out in the production facility, then what we do is we add a neutralizer, so that whenever we expose a plate, it gets neutralized and we get correct results instead of falsification. Okay, so once the plates are ready, depending on the exposure time, so as we have taken the example of OSD, the exposure period varies from company to company. There is no as such a guideline we say that how much time of exposure is required. So at present, in our current facility, we have 4 hours of exposure. So we have to take plates, then we have to go to the area. Okay, if we have to monitor in a particular area, what we do is first, during qualification of the area, we prepare a layout, and in that we mark each location which has to be monitored on routine basis, and the list is there. So based on that, during routine monitoring, with the layout and the list, the analyst takes the plates, he goes to the area, he checks what are the different parameters are required as per the checklist, like whether the temperature of the area is within limit, that is not more than 25, whether the RH, if required, there is within limit, usually it is not more than 60, then whether the area is cleaned or not. Okay, when all these parameters are satisfactory, he exposes the plate. Okay, there is a stand, setter plate exposure stand, which is mostly about 1 feet of height, usually located based on the rational prepared, which is the most sensitive part or critical part, where the organisms can be observed or identified during the manufacturing process, which will give us the true result in what is the condition of the area it is monitored. So the whoever the analyst is there, he exposes the plates, he note down the time, start time, and the rest relevant plates he has to be exposed. So completion, after completion of the exposure, he writes the last exposure time of the plate what he has exposed. So after 4 hours of completion, he comes and again he starts collecting the plates which has exposed first. Okay, so after completion of the exposure, he collects the plate and he comes to the laboratory and he incubates the plate at 20-25 for 3 days, that is for 72 hours, and then next 30-35 for 48 hours. Okay, so after completion of exposure, he note down the colony and he records the result. Okay, mostly for grade A area, the limit is should be absent, means these are the areas where there is no there should be no microbial contamination or colonies observed. In grade B, the limit is not more than 5 CFU per 4 hours of exposure. For grade C, it is 50, and for grade D, it is 100. Okay, so this is related to setter plate exposure. Now moving to air sampling. So based on the during qualification, same like setter plate, we select the locations for air sampling. Now air sampling, in this, the air sampler is used which actively, okay, which actively collects 1000 means 1 CF meter cube, means 1000 liter of air is sucked by the air sampler on the Petri plate. Okay, that is a impingement technique in which air falls on the plate, and after completion of air sampling, the plates are then incubated, same like setter plated, storage condition of 20 to 25 for first 3 days, that is 72 hours, and next 30 35 for 48 hours. So after completion of incubation, we have to record the results. Okay. Now the limits for grade A absent, grade B 10, grade C 50, and grade D 250. Okay. So with this air sampling and setter plate, we come to know what is the flora of that area. Means whether the air what is present in the room, it is as per the requirement or not. Okay. So next part, it is surface monitoring, what we call it is mostly used to check the quality of the cleaning agents what we use. Okay. So for surface monitoring, Rhodac plates are used. Okay. So in it, what we do is ready-made plates are also there, or while preparing the plates, we see that the agar surface is come to an elevated height, rise, so that when we touch the surface of the plate, there is a specific contact, and we get the correct results. Okay. So in surface monitoring, mostly there is a 25 centimeter square centimeter, the size, the dimension is used. Okay. Additionally, wherever the surface which is not convenient to take by contact plates, we use swab method. So in swab, what we do is pre-weighting of the swab is done with a normal saline. Then 25 centimeter square template is there. Okay, in the template, we take a swab by rotating. We take swab of that area by rotating the swab what we have pre-weight. Then that swab is taken to the lab. In that, again 2 ml saline is added, and that saline, okay, in that saline we squeeze the swab, and that sample what we use, that sample is poured into the plate, and in it SCDA is used. Means by pour plate technique, we analyze the sample. Okay. So basically, if the cleaning is proper, or if the disinfectant what we use are proper, we get correct results. Or if the technique, the cleaning agent, or if the cleaning is not proper, we get high result. So depending depending on the count, we have to take the preventive and corrective action, so that the things are in control. So with this in brief, we have covered the environment monitoring technique by settle plate, air sampling, and surface monitoring. So if anyone is having any query on it, please let me.
I'm having one query regarding the sterilization. Can we ask?
Yeah.
Sir, does sanitization, sterilization of any medium, depending on to the size of vessel to which it is filled?
Yes.
And then how to calculate? If there is any kind of formula that how to calculate the sterilization time for that?
Now, see, basically, if we have autoclave, okay,
Okay.
we can check on it. Okay, we will see how it is calculated. In brief, we are having a vertical autoclave. Maybe in lab, we are having a vertical autoclave, right?
Yes, vertical.
Yes. Okay. In that, what during autoclave validation, what we do is we check the lag time. Lag time is the when once we start 121 degrees temperature, when the cycle starts, after that the last sensor which attains 121 degree, the difference between that we calculate, and based on that the time we define that what time we have to set for 121 degrees centigrade. So for example, we have taken a new autoclave and we want to define what time I have to set for 121 degree, or whether I need to increase the temperature, means by 0.2 degree, 0.3 degree. Then accordingly, we have to perform validation. Now validation, in validation, what we have to consider is what is the maximum volume I have to sterilize. Maybe I am having a 2-liter capacity flask and I want to sterilize in it 1 liter of media. So during validation, what I will do is I will add sensor in that flask. Okay. Usually, if the capacity of the autoclave is less than 500 liters, there are 8 sensors which are distributed in the chamber of the autoclave. Okay. One is near the exhaust or the drain, and rest in the all respective directions in the center or at the edge. Okay. So if you are taking a media, suppose you are having 10 flasks of different capacity, so then you have to add in it, we have to cover all the range, min max. Suppose now you're having 2-liter capacity, in that 1 liter media is there, and you have one 250 ml flask, in that you have 100 ml media. So what you will do is in both flasks you will add sensor. Okay. Also external data loggers are placed simultaneously. Okay. So you start the cycle. So once you start the cycle, okay, by what will happen, the autoclave starts its sterilization hold. Okay. Once it reach 121. So once it reach 121, you have to check now from the external data loggers that what is the time required by the sensor, which is in 100 ml media and 1 liter media, how much time it is required. Okay. If you calculate, for example, I have started at 12 o'clock. My sterilization hold starts at 12 o'clock, and I found that 1 liter media, the sensors reach after 10 minutes. Okay. So after completion of cycle, I will say that the lag time is 10 minutes, and I will add 10 minutes in the routine time of 15 minutes. So in that way, we define the cycle time as what we say, 25 minutes for 121 degree. Now, if you want to reduce the time, you have to increase the temperature. Okay. So then simultaneously we increase the temperature by 1 degree or 0.5 degree, and same you have to validate. Usually the acceptance limit is 121 to 124, and depending on the volume of the media you use, you have to define the time.
Okay. Thank you, sir.
Yeah.
Shall we move to the next?
Anyone having query on it?
Nobody.
Okay. So next we'll move to BET, that is bacterial endotoxin testing. Okay. Now in it, how it is, there are no microorganisms involved in it, but we have to check the endotoxin level. Okay. Mostly we get it from gram-negative organisms. So this is applicable for the products like sterility, the products which are injected intravenously, means the products which come into the contact of blood. So for all that, we take the BET test. Okay. Now to understand it in a simple way, there is a technique called gel clot method. There are different techniques. Maybe turbidometric is there, assay is there, kinetic is there, but we'll go with a simple, that is a gel clot method. So as per the chapters of maybe specifications as per USP or guidelines, there is a specific limit of endotoxin which can be allowed during the preparation of the parenteral drugs or injectables. Okay. So to check whether that amount is there or not, we use reagents. So with that reagent, what we check is X amount of reagent, like indicators, when comes in contact with that endotoxin, it forms G gel or the clot, and that clot we have to see whether the clot is firm or not, and on that basis we come to know that there is the desired level of limit is there or not. Okay. The in that what we use is LAL, that is Limulus amebicide lysate. Okay. This is the reagent what we use to check the clot. Okay. Though if you want to analyze a sample, what we do is sample is taken, and depending on its dilution factor, the dilution is made. Then into it LAL reagent is added. Okay. Now along with it, positive control and negative control is also kept to ensure that whether the false result should not occur. So once these reagents are added, we incubate that for 1 hour at 37 degree. After the completion of the after completion of incubation time, immediately we have to invert the tube. Okay. After inversion, we have to check if there is a firm gel clot. If there is a firm gel clot, it indicates that the desired level of endotoxins are available, which means product does not meet the acceptance criteria. If there is no firm gel clot, we have to say that the product meets the acceptance criteria and it can be released for further usage. In positive control, we get clot. In negative control, we do not get clot. So this is the brief about bacterial endotoxin testing. Yeah, please, anyone having any query?
Please ask if anybody is having any type of queries. Okay, sir, continue.
Okay. So next we move to the preservative efficacy testing. Okay. So in preservative efficacy testing, whatever the products, mostly the products like oral liquids, and which duration or the longer dose, like 14 days continuous dose is used. In that there are preservatives. So we have to check whether that preservatives are able to control or sustain the microbial growth. So in it, what we do is around 6 organisms we use. Okay. So we take in basic, I will explain. So in it, what we do is, if we take an example, I will take one example. I want to check whether the preservative what is there in the product is effective or not. Okay, I will take a sample. In that sample, what I will do is I will add known amount of organisms. For example, out of that 6, one is E. coli, second is pseudo. So what I will do, 10 raised known amount of organism means 10 raised to 6 organisms per ml I have to add. Okay, I will take 20 ml of sample. In that 20 ml of sample, I will add organisms in such a manner that I will get 10 raised to 6 CFU per ml. After adding into it, I will do serial dilution. And after serial dilution, I will plate from each tube. Serial dilution I have to do till 10 raised to 6. After serial dilution, I have to plate it out in duplicate, and I have to observe for the results. So after results, for initial day, whatever results are there, I have to note it down. Okay. There are different categories of products having different limits: category 1, category 2, category 3. Okay. So once I get the initial result, okay, so that initial sample what I have spiked with organism, I have to re-incubate it for 7 days. After 7 days, again I have to remove it out. Again I have to do serial dilution till 10 raised to 6, and then I have to plate it out. Okay, after plating out, I have to incubate at the desired temperature. Again, I have to note down the results. So what I have to do is, from initial plating and the results after 7 days, I have to find the log reduction. Okay. So for category 3 products, means which are oral liquids, there should be 3 log reduction from the initial count. Means initially, if there are thousands organisms, then after 7 days, I should find 0 organisms. That is 3 log reductions. Then after 7 days, again I have to incubate for 7 more days. That is for 14 days. Again, I have to do serial dilution till 10 raised to 6. I have to plate it in duplicate. I have to incubate at the desired temperature. I have to, after incubation, I have to calculate the result, and I have to note down and find the log reduction. Now for 14 days, again there should be no increase in the count. That is, whatever the counts were at 7 days, there should be no increase at the 14 days. Okay. So this study is done usually on the new products, means that are the initial products or commercialized, like exhibit first time when they are manufactured, and for the stability studies, it is done. It is a one-time study performed for that particular product. Okay. So this was brief about preservative efficacy testing in brief. So if anyone is having query, we can discuss. Yes, anyone please?
So is preservative efficacy and vaccine efficacy are the same terms?
Which one, preservative and?
Vaccine. Can you hear me, sir?
Yeah. Preservative and what second term you are used?
Vaccine. Vaccine.
Vaccine. No, I'm not clear about vaccines.
Okay.
The alternative name for preservative is antimicrobial testing.
Yes. Because present days there is a controversy about the efficacy of the different type of vaccines which are produced against the
Okay.
COVID.
Okay.
Hence I asked this.
No, I'm not just clear about vaccines.
Okay. So shall we move on?
Yeah. Okay. So now next will be related to sterilization. Okay. So basically, as you all must be aware of sterilization. So D value, Z value. Okay. Additionally, there is a F0 value also. So in brief, already I have explained what is validation in it. So during validation, what we do is we use chemical indicators as well as biological indicators. Okay. So for example, now vertical autoclave we are having in a lab, and we have to validate it. Now, how we will validate it, or how we will ensure that whatever we are doing is sterilized properly. Okay. So initially what we do is we do a validation study. In that we do one empty cycle run. Now in that your autoclave must be having your fixed proofs, maybe 2 sensors, 3 sensors, or 4 sensors, and additional data loggers. Means additional sensors we have to add in it to check whether it is giving the same desired result as per your autoclave's internal sensors. So for vertical autoclave, one sensor we have to place at the exhaust point from where the steam gets out, one at the centers, and rest at the specific location what you have designed. So first you will run an empty cycle. So then in that empty cycle you will come to know that at the exact time at which your autoclave cycle gets start, the data logger sensors also should show 121 degrees centigrade. Means which indicates that whatever temperature in the autoclave is, it is uniform. So next comes your media load. Media load, okay. So in that, as per earlier discussion, depending on your load size, you have to design and you have to place the media in it with along with the external data logger sensors what you have in it. From that external data logger sensors, after the sterilization starts, you have to record which sensor of the data logger comes last. So that will give you the lag time. So once you got your lag time, you have to decide the time for sterilization. 15 minutes, the ideal time is there at 121 degrees centigrade. We have to add lag time in it. Suppose my lag time comes 10, you have to sterilize at 121 degree for 10 minutes. Okay. So that is your D value. The D value is nothing but the time taken for 90% reduction of the organism. Okay. Now you want to say that, okay, now 25 minutes is a lengthy time. So what can I do is I have to increase the temperature. Okay. So if I increase the temperature by 0.5 degree and my time is reduced. Okay. So the time, sorry. So if you increase by 0.5 means instead of 121, you will run the cycle at 121.5. So again, you have to carry the same validation. You may find that the 25 minutes, whatever is required, the time has been reduced to 20 minutes. Okay. So that way, now during this, the main thing is how to ensure now I'm getting data is okay, but actually whether this will kill my organisms. Okay, to ensure that we place chemical indicator as well as biological. In that chemical indicator, there is a temperature sensitive indicators are there in it. Usually TST Brown indicators or SYLLABUS indicators are used. So in that we come to know that color change means if I'm exposing that indicator for 121 degrees centigrade for 10 minutes or 15 minutes, the color will change from yellow to purple, or it may change dark brown. Okay. And for biological indicator, okay, so these are organisms, means same like injections what we have during, you might have seen injections like that, the ampules are there. The difference in it is having a indicator, media and organisms. That spores are there. The organism is Geobacillus styrothermophilus. Okay. So it is heat resistant organism. So what we do is during validation, where the 8 sensors are placed at that same location, we keep these ampules. And also during the sensor, when we are placing it in media, we insert that ampule in the media. Then same sterilization activities performed. After that, we remove the ampules and we incubate that ampules at 55 to 60 degree. So if the organism is alive, means if that spores are not killed, it will germinate. Okay, the earlier color is purple, and after there is acid production, the color changes and it goes to yellow. So if there is change in color, it means that your your sterilization is not proper and you have to revalidate your cycle. And if sterilization is proper, there will be no color change. Along with it, we keep that is the biological indicator which doesn't have organism. So to stimulate that, whatever we are doing is with correct procedure and method. So this is brief about sterilization of media or autoclave. So additionally to this, during routine media what we prepare, we perform the growth promotion test. So the growth promotion test is nothing but that known amount of organism for the desired media. We spike it. Usually there are two parts. One is indicative and the second is inhibitory. You might be knowing that for McConkey's agar, if you want to do check, we use E. coli, that is an indicative organism. Okay, and inhibitory for mannitol salt agar if we use, we have Staph aureus as an indicative and E. coli as an inhibitory. So after sterilization, if my media is sterile, I will get no contamination in it. And if there is improper sterilization, I will get contamination. Okay, anyone has a query on or any questions? Sorry.
What if there is excess sterilization?
Okay, though if there is excess sterilization, in that I will come to know the characteristics of the media has changed. So during that, if you perform the growth promotion testing, if there is excess sterilization, if the nutrients are exhausted or they do not support the growth, your organisms what you are using will not grow. Or whatever the limit is behind. Usually the guideline limit is if you are spiking 50 organisms, the required organism should be within the factor of 50. That is 50 a factor of 2. That is lower limit will be 25, higher limit will be 100. So if you are getting within this range, that means you are having the nutrient properties as per the requirement. Also, if there is a color change, we have to discard the media. If the physical properties of the media are damaged due to excess sterilization, we have to discard the media.
Okay. Thank you.
Okay. Hello.
Yes, sir.
Yeah. So moving to the basic concept of now lab design, or how should be the lab. Okay, a little bit theory part in it. Okay, I will not go much into the detail of class biosafety lab class 1, class 2, class 3, class 4. So, but in brief, how the pharma lab is, that details I will discuss. For the rest, as per the syllabus, I will share you the technical details or the notes which you can refer for additional knowledge. Okay. So, if you want to set up a lab in a pharmaceutical industry, so basically what you need is a core area where you have to perform testing. Okay, it is usually a class C, okay, or class B area, that is, and in that you have to place a biosafety cabinet or LF, what we call, that is the core area. Okay, so to move into the core area, we have a change rooms. Okay, so where we perform the gowning area, gowning process. Okay, in sterility area, if you want to move, there are around 2 preliminary airlocks moving to the core area. And for MLT, little bit less stringent, we have one airlock where you do gowning and you have to move inside. Okay, so surrounding the core area, what we additionally require is supporting to it, that is a media preparation room. Sterilization, for sterilization we require autoclave, then we require incubator. So usually whatever testing we do, if the products are related to human consumption, that all we are having has been the organisms which are there are all mesophilic, means as per the body temperature 20 to 25 degrees centigrade can incubator, and next is 30 to 35. Okay, so these incubators are required. Then we require a dedicated washing area where whatever activities the samples what are analyzed are to be washed properly, and whatever the biomedical waste is generated has to be decontaminated. So dedicated one vertical autoclave is required. Apart from that, we require additional room for the storage of media or whatever requirement are required for routine analysis. Okay, then the lab, what is to be designed, it will be a controlled area lab, meaning it the temperature, humidity, or the entry access to this area is restricted, means only the authorized person to these labs are allowed. Okay, usually the controlled area ISO 8 or beyond that, and the core area is ISO 7, that is a class C or class B. LF will be always a class A area. Now, when you want to transfer a material to the core area, it is transferred to the pass box. In that pass box, it will be static pass box or dynamic pass box. Okay, the area is the temperature and humidity in the area is controlled by HVAC system, high ventilation air conditioning system. Okay, so in that temperature and humidity are monitored. We require purified water system, which is required for preparation of media, and potable water system, which is required for washing and other accessories. So in general, this is the basic requirement of the lab. Wherever you go, if you are having sterility testing area, there will be a separate sterility testing area apart from MLT area. Also, there is a dedicated culture handling area in which the culture handling takes place. So at present, in where I'm working, in that there are one testing area of culture dedicated, one MLT area, one sterility area we have, one media preparation room, one washing area we have, one storehouse we have, where all the materials which are required for testing are kept. So this is the brief overview of the lab. Also, I will be sharing you the details of the standard laboratory, how it should be. Hello.
Yes, sir.
Yeah. So if anyone has a query, you can ask.
So I think you're all done, sir.
Yeah, from my side, it is all done.
Yes.
If we have any points to discuss, we can have. All the resource related materials I will be sharing to you with the reference USP chapters and all that things. So it will be easy for the students to have additional knowledge and to see what are the practices involved in it.
Okay. If any participant is having any type of question, they can share. Thank you, sir. Even with your busy schedule, yeah, you had contributed a lot of time with us. And even though without any presentation, your explanation was quite fruitful for all the students. So thanks a lot again from bottom of my heart. And I would like to announce to listeners that Balmik sir is going to share some details about his explanations to our department later on. Thanks a lot, sir.
Thank you. Thank you.
Okay, finally, we are reaching to the last speaker today, Mr. Avinash Rohidas, who is Assistant Manager in Glenmark Pharmaceutical, Goa. He will be dealing with the Quality Control Microbiology, a theory paper. I would like to request Mr. Dr. Avinash Raut, sir, to introduce our next speaker.
Thank you, Kirti madam. Mr. Avinash Rohidas is my classmate, actually. He's from 2006 batch, MSc Microbiology at Yashwantrao Chauhan College of Science, Karad. He has completed his Bachelor's of Science in Microbiology at Rajaram College, Kolhapur in 2004. He has completed his MSc in microbiology at YS Yashwantrao Chavan College of Science, Karad, in 2006. He's, he has worked as an analyst from 2006 to 2010 at Cipla Limited at Goa. And he's now presently he's working as an assistant manager at Glenmark Pharmaceuticals Limited at Goa since 2010. His expertises are in his expertises are at non-sterile formulation of oral solids, semi-solids, and the hormones, oral solids as well as the products. He is also involved in review and planning of quality control microbiology. Then he's also involved in preparation of GMP documents, VMP, SOPs, protocols. He's also expertised in stakeholder coordination, handling of regulatory audits. He is also an analyst in qualification and execution of training to the analysts. Then he is updating and review of specifications and test procedures. He has expertise in evaluation and assessment of change controls, incidents, OOS and OOTs, and deviations. He also knows the laboratory investigation of incidents, deviations, OODs, and OOTs. Now, he is a FDA certified analyst. He is also a CDSCO approved microbiologist for testing of microbiological analysis. So I'd like to request Mr. Avinash Rohidas to take over the session now. Thank you.
Thank you, Avinash. And it's my pleasure to share you my experience regarding whatever the Avinash shared me your syllabus. So I don't know how to go through it because I have no, I'm not well prepared about it. But definitely I can share you my experience related to all these topics like GMP is there, then all the microbiological analysis is there. So these topics I can share my experience like bacterial endocrine test, then bioburden test. So these all tests I gone through means I conducted this test long time back, like 2006, 2002, 2010. After that, I am in a managerial role. So definitely some I can skip some steps. So you just manage about it. So we'll start with the GMP. So I will present the PowerPoint. Is it okay to share the PowerPoint presentation?
No, sir, screen is not visible to us.
You can share your screen.
Yes.
Okay, yeah, now it is visible.
Is it visible now?
Yeah, yeah. You
Yes.
take it in the mode of PowerPoint presentation. Okay, now it's fine.
Okay. So basically quality management system in pharmaceutical manufacturing. So the GMP that we talk about in the pharmaceutical, why it is important? Because when we manufacture the product, so it is very difficult for the patient to check the quality of the product by just looking at the tablet or by just smelling it or by touching. It is not possible for patient to check the quality and the efficacy of the product. So it is good manufacturing practices comes in a picture. So most all the pharmaceutical manufacturing industries that we have in India, in all over the world, needs to follow the good manufacturing practices to ensure that, because the pharmaceutical manufacturers produces, for example, 1 million of tablets, but they test only 100 tablets, for example. So it is not possible to test whole lot of the product manufacturers. So what we do is, what the pharmaceutical manufacturer do is, they uh, follow the good manufacturing practices. So good manufacturing practices is nothing but like how to manufacture, like SOP wise. There is a, for example, if you cook the someone product, one vegetable or something like that, we have the recipe. Like that, we have the manufacturing practices to manufacture the pharmaceutical product. So these are some definitions. This all I will share the definition, all the literature part I will share with you. The QMS, a quality management system, is the core of any quality compliance process. This is all theoretical. Good manufacturing practices system of ensuring that the products are consistently produced and controlled according to the quality standards. It is designed to minimize the risk involved in any pharmaceutical production that cannot be eliminated through testing the final product. And the HACCP. HACCP is generally followed in the food industry. It is not followed. It is not. I'm not saying it is not followed, but HACCP terminology is more used in the food industry. So these are the, if you see the quality management system, whenever we talk about the quality management system, these are the 7 pillars like training, documentation management, validation, change management, maintenance, supply management, self-inspection. Training means whatever the employees that we have in your pharmaceutical industry, in production personnel, then your quality control personnel, then quality assurance personnel, all should be trained for relevant SOPs, relevant procedures. Then documentation management, how we manage our documents like SOPs, the procedures, then the validation, then the change management. Whatever, if you want to do some changes in your SOPs, then it is a change management procedures. Then maintenance, whatever equipment we have in pharmaceutical industry, so their maintenance. Then supplier management, whatever we procure from the outside, like raw material, for example, packing material, so their management. Then self inspection, like how we inspect ourselves, how we audit ourselves. So these are some, like, this is a basic model whenever we talk about the quality management system, or is there any training of the quality management. This model is surely, you can see the 7 pillar model of the QMS. Can I play the video? Unless the video is audible to you, you can see the video. Hello.
Avinash,
Yes,
it's not audible.
but you can see the video, no?
Yes, yes, we can see it.
Designed to give you an overview
Now
of
it's audible.
manufacturing
Yes.
practice, or GMP, and the quality system used in the manufacture of medicinal products.
A firm understanding of the importance of quality and good manufacturing practice, or GMP, is essential for any career in the pharmaceutical industry. This course gives a brief history of the regulatory roadmap.
So whatever the regulatory requirements that you have in your syllabus, like US FDA, then MHRA, these all are governed. This is all like, they all covers this GMP practices.
Which has led to the regulations and quality systems that are in place today have the required quality. This includes the people working in the plant and the design and management of the premises, equipment and utilities. The processes we use are well defined and controlled, while the procedures in place clearly document how each task is to be performed. The product itself needs to be traceable from start to finish. Moving on, the concept of Quality System Element, or QSE, is introduced. This is a business process which forms part of the pharmaceutical quality system. We've broken it into 15 quality system elements in this course. An overview of each of these is provided. First, quality assurance. Next, premises and equipment. This is followed by calibration. The next QSE is technology transfer. This involves transferring processes from development.
Technology transfer is nothing like, suppose if we design a product, so what we do is, first there is a pilot scale production and then the testing. So once the pilot scale gets succeeded, then we transfer it to the commercial level. That is the technological transfer.
To production, or from one manufacturing site to another, while ensuring the product quality is maintained. For training, all personnel need to adequately perform their assigned roles. Personnel are trained during induction, when roles are changed, or
The training in the good manufacturing practices plays a very important role. So now the system is upgrading in the pharmaceutical industry, where we all have one online platform for the training. So whenever there is a change in any procedure, for example, if you see in my microbiology department, we have around 200 SOPs. So it is not possible for a person to go through all the changes in the SOP if that happens. So what we do is we get software, so where we can, where there is a notification comes is there is a change in the procedure. So these all are the updates now happening in the pharmaceutical. Training is a very important role in the pharmaceutical industry right now, currently.
Whenever changes are made to how a task is performed. Training is therefore an ongoing exercise in any manufacturing facility. The QSE of good documentation is a huge part of GMP and working in the pharmaceutical industry. This course teaches you all about the hierarchy of documentation. You'll learn about typical GMP documents like the Batch Manufacturing Record or BMR.
So whatever you quoted, you have mentioned in your syllabus about the batch manufacturing record. So this all is the batch manufacturing record. This is the template of the batch manufacturing record. So whenever one batch is getting manufactured, so the production personnel fills all these forms and all. So this is generating but the batch manufacturing, starting from the raw material. So how much of the raw material you weighed, how much amount, which equipments that you have used, the any intermittent weighing, then weight printouts, everything is attached in the batch manufacturing record. Once the batch get manufactured, it goes to the packing. So it is called batch packing record, that is BPR. So if there is anything complaint comes, so if you just see the batch manufacturing record, you will come to know whatever happened in the batch, starting from receiving of the raw material till the testing.
You'll also cover how to make corrections to entries in GMP documents, which is standard practice in the industry.
So this is like good documentation practices. Suppose if you do something wrong, the spelling is wrong, if you have done something wrong entry, so you have to strike it out a single line, then you have to make a cut sign, you have to sign it there, you have to put a date, and then you have to write a remark. So this is all the documentation practice, that is called good documentation practices. Then you have to use, for example, if you see the CIPLA is having a quality control person use only black pen, the production person use only blue pen. So different industry wise and different industries and different practices. So just to maintain the documentation, good documentation practices.
For the QSE supplier qualification, careful selection and management of our suppliers is key to ensuring consistent quality of finished products. Next, QC testing and stability. The QC lab tests raw materials, products in the process of being manufactured, as well as finished product and environmental samples. The QC lab also manages the stability program, which supports the shelf life of our products. To cover the QSE validation, the course provides an overview of validation documentation, as well as equipment qualification, process validation.
So if you see the validation is like, suppose if you develop a process, you have to validate the process on a yearly basis or the frequency wise, so that we can say that yes, this process is continuously giving me the same results, like how the recipe is there, the cooking recipe and all. So for example, if the pizza outlet, they are having the recipe for the specific pizzas, so they don't change that. So it is like it will give you the consistent quality. So same way we have in our pharmaceutical the process. So it needs to be validated on a frequent basis.
By the industry. The next QSE is recalls.
That issue, it's important.
This is followed by covering the QSE investigation and CAPA.
Of any issue through making uncontrolled or improper changes to a validated process.
This is followed by covering the QSE investigation and CAPA.
Suppose something wrong happens in the validation process or something wrong happens on a process. So what we do is we have to do the root cause analysis, why this has happened. So once if you understand the root cause, that is why this has happened, maybe the person is not trained well, like that, or there is some problem with the equipment. So what we do is we rectify the problem. And there is a corrective action and preventive action. It is called kappa, corrective action and preventive action. We correct the error and there is a preventive action, so that in future this problem will never occur. So that is called corrective action and preventive action.
Of any issue in manufacturing or in the labs or within a business, it's important to do a proper root cause analysis or investigation into that issue to ensure that you've found exactly what caused the issue, so you can address that issue and put in the proper corrective actions or preventative actions if you found something may happen again in the future.
Audits may be internal or external. It highlights any potential weaknesses in our system and facilitates continuous improvement. For the QSE of customer complaints, these are taken very seriously by the industry and need to be investigated thoroughly. The next QSE is recalls. There are times when a company needs to remove batches of product from the marketplace. There's a process for performing a recall, and the relevant regulatory authority needs to be informed.
Wherever there is a recall means there is some problem with your product. So there is a complaint received by the patient. Maybe we get a complaint by the patient, or maybe it is by the Food and Drug Administration. If it is in India, you upper CDSCO, or in the US, if the product is in US, then US FDA. So what we do is there is a product recall. We have to recall the product from the market, even from the patient's hand. Like if it reaches to the patient, we have to recall that product. So there is a procedure called mock recall. Mock recall is like you have to demonstrate your recall procedure. So suppose something happened in the future, how quick you can recall the product from the market. So that is called product recall.
The final QSE is annual product review. This is a systematic review of a product's performance over a calendar year. Content can be reviewed at the learner's own pace.
So moving towards this hazard analysis critical control point, that is HACCP. So HACCP is an internationally recognized method of identifying and managing food safety related risk, and when central to an active food safety program, can provide your customer, the public and regulatory agencies assurance that a food safety program is well managed. So as I said, the HACCP hazard analysis critical control points are mainly concerned with the food industry. So I will share you one video so that you will understand what is this. This is all a theoretical part, the principle, conduct a hazard analysis. These are the 7 principles: determine the critical control point, establish the critical limits, establishing monitoring procedures. It is like you have to analyze one hazard. If there is a process, you have to analyze that this hazard may happen. For example, if there is you can say, a safety hazard. For example, if there is an open wire or live wire, so this is like a hazard, so you have to analyze. So then you have to determine the critical control points, then critical limits, then step monitoring procedures. So then the corrective action that I explained, the verification procedures, then record keeping, documentation procedure.
Back about our which we must have a small brief about the HACCP. The HACCP system was first introduced in the 1960s in NASA to ensure food safety for astronauts. The application of HACCP system, in addition to the prerequisite programs and the GMPs, the good manufacturing practices, provides the
good manufacturing practices, and HACCP is a little bit similar.
Best protection for food.
The aim of both the system is to assure our product is quality, and there is a safety and the efficacy.
Food. The application of the HACCP system ensures that the company controls all the types of hazard. If it is physical hazard, logical hazard, and juice will train ourselves how.
This is a very good example of HACCP plan. So like orange juice manufacturing industry, so how they will have their HACCP plan.
How to can make an HACCP plan for any food we want to make has a plan for it. Let's understand the 12 steps, the 5 primary conditions. Number 3, the intended use and consumers. Number 4, draw a flow diagram to describe the product process steps. Number 5, on-site confirmation of this flow diagram. Our example was the orange juice. So the HACCP team for this orange juice in this company will be from different departments: top management, quality and food safety, production, sales, maintenance, and purchasing. And we will understand later on what the benefits and the...
So first, what we have to make the HSSC plan is we need to form a team from the different department, like he mentioned, the production department, maintenance department, purchasing department, quality control, quality assurance.
Importance of each department for those departments. Number 2, for the orange juice, we must have a description for the product, components, and storage condition. For example, this orange juice, our natural pasteurized orange juice, this is the description, and its components was orange plus water. Specifications, it's sugar-free, and methods of preservation: stored in the refrigerator in temperature from 4 to 8 Celsius. This is an example, okay? We also can of the bottles. The intended use, we can mention that it can be drank directly from the bottle. The user category, for example, from age of 2 years old, and not recommended for patients with pressure. This is an example, okay? We must mention.
So whatever he's explaining, like assemble the HSCP team, describe the product, the intended use and the consumer. This is all the steps to make a HSCP plan.
If there is any medical precautions, must be mentioned on the label of the product plan. Main receiving all the orange from a well and trusted supplier of orange fruits by harvesting this orange fruits. But the mentioned first step was the receiving of orange. You must take care and to focus on the shape of the step, okay, and numbering of the step. For example, number 1, receiving of orange. Number 2, sorting of orange. This shape was rhombus shape. It means that there is a decision if it is good orange fruits.
So now if you see sorting of orange, the oranges which is having a bad quality, first they remove. So it is called the hazard. So for example, if these bad oranges comes in your production line, ultimately the quality of your oranges will affect. So this is the first hazard, that sorting of orange. So this is the first step. Like this, step by step you have to find the hazard. So this hazard is, you can control it. How you can control? You can make a person there to monitor the oranges when or sorting of the oranges. So like every hazard, you should have a critical control. That is called critical control points.
Or bad orange fruits. Number 3, washing of this good orange.
For example, if you sort out the good oranges, but if you are not washed it properly, so that might affect the quality of the product. So this is another hazard, like washing. So the washing is a step so that we can remove that hazard for the dirty orange, to clean that orange. So washing is a critical control.
Fruits and the drain of the waste water. Then this orange fruits will be squeezed out. Step number 4. Number 5, filtering to remove any peel or seed. Number 6, concentration, because it's a natural juice. Number 7, reconstitution by adding water. Number 8, pasteurization, heat, then sudden cooling to kill any microorganism. Number 9, bottles filling. You must take care, for example, between differentiation of step number 5, filtering, it's a rectangle, and step number 8, pasteurization, it's a document shape flow chart diagram. Okay, you must take care of this. Bottles capping. Number 11, X-ray, okay, to make inspection if there is any residues in the bottle. Number 12, dating the bottles. Number 13, packing the bottles. And number 14, arranging on pallets. Number 15, the storage of the temperature. The step, the distribution. Our flow diagram. Number 1, receiving of orange. Fruits. Number 2, sorting of orange and Sarambas. I have mentioned before this decision, so there will be waste. Number 3, washing. You can find that waste shape was a rounded rectangle. It means last step. So after waste, there is no any step in our production process. Number substitution by adding water. Number 8, pasteurization. Number 9, bottles. While explaining in the up for each step, the document, and number 11 also it's a document flow diagram shape. So process step number flow chart diagrams bottles. Number 13 and number 11 of the hazard analysis for each step. Okay, identify the critical control points, establish critical limits, monitor our CCPs, establish corrective action, and verification. Number 7, record keeping or documentation. The next 7 basic principles for HACCP will be explained in the upcoming videos, but
So next we will talk about the auditing of the microbiology laboratory. So generally the microbiological laboratory is inspected, even maybe the USFDA inspector or your routine self-inspection. So generally what we see is in the USP there is a chapter 1117 that is called best laboratory practices. So these chapters deals about what you do in a how to do in a microbiology laboratory. So according to that chapter, they might monitor, they inspect your microbiology lab, like good housekeeping, then sample receipt, how the sample getting received, where you store the sample, is there any temperature control or not, whether the temperatures are recorded or not.
Hello.
Hello.
Yes, Avinash.
Yes. Okay.
You are clicking something over there.
Okay.
Okay.
So this is the chapter that I was talking about, like microbiological based laboratory practices. I will share these documents. So it is having the media preparation, like how to prepare your media. So whatever they are having some water is the universal dialogue. I will give you an example. So for example, see in the media preparation, you have when you prepare the media, you have to check for the appropriate inspection of your plates, like cracked containers or lids, unequal filling, dehydration of resulting in cracks, excessive darkening. So all these steps the inspector checks. So if there is any problem in that, they will note it down. So same way like media storage, then laboratory equipment, then maintenance of your microbiological cultures, whether you verify your certificate of analysis for the cultures or not, then your laboratory layout operation, then the training of your employees, then how you handle the samples, then the how the media is getting incubated, and how the testing test analysis media is getting incubated, then all your documentation practices and all the maintenance of laboratory records. This is all actually the theoretical part. There is nothing to explain. So I will share this document so you can go through it. So accordingly, by these chapters, by the GMP chapters, the auditors ask you the questions and audit your microbiology laboratory. So all these GMP practices and these base laboratory practices, you can say, you have to follow. We'll move towards the next chapter about the microbiological analysis, the drug regulatory affairs, clean room and environmental monitoring, and the bioburden and the endotoxin and pathogen testing. So the regulatory affairs. So regulatory affairs, you can see it is a very good, I can say, uh, topic, and you can means there is a very good chance scope in for the career in the regulatory affairs in pharmaceutical industries. So there are very few people who actually know about what the regulatory affairs is, or who knows about all these guidelines and all. So if you can tell your students about to go pursue a career in the regulatory affairs, it's a very good. So for the regulatory affairs, you have to, I think you have to go to the post graduation course in science stream. After that, you have to have this regulatory affairs course. So it is like the bridge between the pharma company and the government agency. The government is like US FDA or our CDSCO. So what they want. So it is like a bridge. There is a person in there is a in each pharmaceutical industry there is one person who deals with this, like regulatory body and your company. So these are the drug regulators like US FDA in USA, EMA European Union. Then we have MHRA in United Kingdom, like CDSCO in India. Then Ministry of Health and Family Welfare in Japan. Then TG Australia. So we have most of this in our landmark, like USFDA. We have gone to this MCC, then MHRA, TGA. If the industry is in India, then you must go to this. You have the CDSCO inspection, that is mandatory. Even Health Canada may add. So what these pharmaceutical regulatory bodies are always keep on challenging for the following, and they are like to promote public health and protect the public from harmful and dubious drugs, to establish proper legalization covering all products with a medicinal claim and all relevant pharmaceutical activities, whether carried out by the public or the private sectors, to increase worldwide regulatory growth to ensure safety of people. It is like there is a guideline in the there is a guideline for the regulatory, and you have to comply that guideline. That's also the regulatory affairs job is like that only. FDA is a US FDA. Like now I'm saying about I'm talking about US FDA. The US FDA is the US federal agency responsible. So US FDA has nothing to do with this USP general chapters. What we talk about the general chapters like USP chapter, like what I shared earlier, like USP 1117 and all. Or I think the Valmik also shared something like USP. I was mentioned about USP general chapters. The USP general chapters and US FDA, as there is no any connection. But US FDA takes US general chapters for this inspections. So you have to follow US general chapters, but there is no any direct connection between US FDA and general chapters. So general chapters is just a guideline, and US the US FDA is self-sustained, like they don't have any government role, they don't have any government agencies. Just the US government is accrediting them as a Food and Drug Administration. That's all. But there is no any government, and US FDA are both are different entities. FDA is responsible for ensuring the foods are safe. There are safe, wholesome, and sanitary human and veterinary drugs. Biological products and medicinal devices are safe and effective. Cosmetics are safe, and electronic products that emit radiation are safe. Evidence that these products are honestly, accurately, and informatively represented to the public. Okay. So why the FDA conduct inspection? So I will share, maybe you know about this Dinesh Thakur story about the Ranbaxy. Anybody has know about this Ranbaxy story? Dinesh Thakur. Anyone heard of it? Am I audible? Hello.
Yes, sir.
Am I audible to you?
Yes, yes.
So why the US FDA inspection? Why it is important? If I want to tell you a story, there is one Dinesh Thakur from the Ranbaxy industry. He was working with the Ranbaxy on 2002. So after that, he moved to this India Gurgaon plant. So there what he observed is there is a very I can say fabrication of the documents, like the results are like this and they manipulated the results so that they can enter the market before any other player comes in the market, so that to achieve the profits and all. So what he did is he informed this to the US FDA. So that time there was only 4 inspector who was looking after this Indian Indian pharmaceutical industry. So in 2004, I guess, he informed the US FDA that there is a serious malpractice happening in the Ranbaxy. So after that, there is a coordination between Dinesh Thakur and this US FDA. After the 8 years, the Ranbaxy, you know about what happened to the Ranbaxy. Then I think around $46 million, they had to $48.6 million is given to the Dinesh Thakur for this, because he is a whistleblower for this case. And I think $2,714 has to Ranbaxy has to pay to this US FDA. So then after that, there are 15 more inspectors as they have recruited in the India. So now after that incident, the inspection has started. So the USFDA generally conducts these 4 types of inspection, like pre-approval inspection. Before entering into any before launching of your product, we have to do the pre-approval inspection. Or if you have a new industry like new pharmaceutical industry, you have to go through this pre-approval inspection. Then there is a routine inspection like year wise or 2 year wise, whatever. Then the compliance follow-up. Suppose there is a problem with your industry and they have given you a form, like form 483 is for the non-compliance with the GMP, like 484. There are so many forms. So to comply that, whether you have corrected that error or not, to check that is the compliance follow-up inspections. Then for cause inspections, like recalls and market complaints, that is called for cause inspection. Then when the organization makes a submission to the FDA, for example, we are launching a new product, so that time they do the pre-inspection. When the organization makes a submission to the FDA requesting to market a new product, then FDA conducts pre-approved inspection. So to verify the submitted data, the data is correct or not. So to check that, they do the pre-approval inspection. There's a routine inspection that we generally go through. These types of inspection are mandated by law. Risk-based approach is being used to determine inspection frequency. So the general approach of this inspection to check whether you are following your good manufacturing practices or not. So inspection can be initiated on any given day as per the dates proposed by the FDA, and the organization should conduct the operations and always be prepared and ready for an inspection. Then the compliance, like this type of inspection are being conducted in case the organization firm was issued significant 483 observation. 483 observation is nothing but you are not complying with any of these good manufacturing practices. So they give you a 483 observations. So if you doesn't comply, then there is an import alert. Import alert means you can't import your products to the US. So they're having a serious penalty. Like suppose I'm giving you one example. Suppose if we committed 1 million of tablets, for example, paracetamol to the US, for example, on 1st of April. So if you fail to for example 1 crore rupees, for 1 crore rupees 1 million tablets of paracetamol you are committed to the US right now. So first of April, if you are not made that consignment, if your consignment is not delivered to the US, they give you a serious fine. They charge you a penalty. Like if the deal is done for the 1 crore rupees, you have to pay 1.5 or 2 crore rupees to them, and they will not allow your product. Then once the 1st April, if the 1st April you have not able to deliver these products, they will charge you 1.5 crores. Then forget about your 1 crore and all. So there are various serious penalties is imposed by the US FDA. So you have to, when we talk about the month end, like this is a month end right now. So like month end, quarter end, we have these dates. Like 1st of April, I have to give this 1 million of the tablets and all. So if you don't follow it, there is a penalty. A penalty is like huge. If you have committed a 1 crore rupees, then you have to pay them 1.5 crore without delivering anything. So this every inspects and verifies the action corrective actions. Okay. So the 4 cause inspections. So these are all the forms that is issued by the USFDA, like Form 480, Notice of Inspection. Like when they are going to come, they give you a Form 480, 483 Inspection Observation. When they observe they have observed any error in your inspection, they give you Form 483. When on the news or in the business news, for the company, for you will read that for example, this company got the Form 483 observations. So this is the Form 483 is a number of the form. Then Form 484 receipt of samples, that is for the new product. So these are various forms. So this is all like theoretical. What should you do during the FDA? FDA inspection is like how we conduct the elections in our country. It is like that. The FDA inspection is a very big thing, like US FDA. For the pharmaceutical is a very big thing, because if something happens wrong, then there is a complete ban of your products. And forget about the ban, you will get the front page cover on the paper, newspapers and all, and there will be a huge stock market loss. There is so many things. So for that's why the USFDA inspections or any audits is a very big thing for the pharmaceutical industry. So it is impossible for us, any one of us, any of the pharmaceutical industry to come back for that. For example, if you take the example, there is a very typical example, Ranbaxy. There is a very it is not possible to for the Ranbaxy to gain their position again. So when see, these are all of the points, what should you do during the FDA inspection? So the organization and confidence should project a favorable impression with the FDA inspector. Upon their arrival, escort them to the front room. The front room is generally a designed conference room. So whenever the inspector comes, they comes with their laptop. The laptop is having one their unique password. You can't touch their laptops and all. There are so many things. The front room is generally a designated conference room where the organization management. So after that front room, we have the war room. War room, like where all the top management people sits. When the FDA differently requests document or records, it should record the request in a log and forward it to your designated back room. Back room is like war room to complete the request. So if they ask you any type of document, there is a timeline. So within that timeline, if you don't provide them document, that means they consider it as the document is not available. So it is like that. You can't say that the document is there, then we'll get the document. The person is searching the document. You can't say like that. So So I will share this. It is like theoretical only. So whenever we give any document to the USFDA, so there should be one person should note down which document is given to the USFDA. It is all record is maintained. Everything is maintained. So this is about regulatory affairs and all. We'll move to this. microbiological analysis. Within next 15 minutes, I will finish. So these all testings is performed in QC microbiology, like environmental monitoring, utility testing, sterility testing, microbiological content testing, like how much microbial load is there, bioburden, microbial limit, bacterial endotoxin, microbiological identification, antimicrobial effectiveness testing, cleaning validation, MEDAFILs. So in environmental monitoring, we have water and clean steam monitoring, air monitoring, non-viable, viable. So viable, non-viable, you should know what the viable is, what non-viable is. Non-viable is like particulate matter. So they have one machine which collects the particle, filters it, and measure the particle size and all. Microbial surface monitoring means Rodak plates, like small plates that will be 55 mm, then gown and fingerprint Rodak testing. So these all testing happens in pharmaceutical industry. So there is nothing like to explain. So these are the guidelines for the clean rooms, Federal Standard 209 guidelines 1464. These guidelines I will share with you so that you can have an idea about the limits and all. So this is ISO class. I think the Valmik was sharing with the classification like grade C and all. So ISO class 5, ISO class 6, ISO class 7, different guidelines having different terminology. ISO is having ISO class 1, 2, 3, 4, 5, 6, 7, 8, like. Then USFDA is having grade A, B, C, D. The meaning, the limit will be the same, only the terminology will be different. So for example, ISO class 5. So 0.5 micron, 3520 particles are allowed. Then 5 micron, 0 particles is allowed. Generally 0.5 micron and 5 micron we measure in a particular matter. This 0.5 micron and 5 micron is having a significance for the ISO class 5, 6, 7, 8, 9, 10. In microbial animal monitoring, we do passive monitoring, active monitoring. Active monitoring is like a vacuum pump is there in the instrument. So it actively sucks the air in the environment, and this the air will settle on the split. Passive like settle plate, like we keep the plates in a designated location, and by the gravity, the particles will come, a particle will come and settle on the plate. Then we count the colonies and all. So general this microbial air monitoring, whenever it is what I'm telling you, because microbial air monitoring is whenever we go for the interview, so they know that the students, when we go for the interview, the interviewers should know, the interviewer always know that they don't know about anything. So what they do, they start with the microbial air monitoring, environment monitoring, because it is a basic what you can say, basic concept of the industrial microbiology or pharmaceutical microbiology. So try to tell your students to emphasize on the environmental monitoring subject, because during the interview, this is the main subject for the interview. Whenever I interview for the students, the fresh students, so I generally use this environmental monitoring because it is a very simple technique. So with this knowledge, they can judge. Endotoxin testing, like I'm having one. Okay. Endotoxin testing, I will explain you later. First, we'll finish with this bioburden test and MLT test. So this is a basic comparison about bioburden test and microbial limit test. The microbial limit test, the name is now changed to the microbial examination of non-sterile products. So microbial limit test or microbiological examination of non-sterile, it is used in the non-sterile formulations. Like whenever we test the tablets, non-sterile tablets or the oral liquids, which are non-sterile in nature. So we do microbial limit test or microbial examination of non-sterile products. And the bioburden test. Bioburden test, it's like we have to measure the bioload available in the products. For example, in a sterile facility, there are so many processes, starting from the manufacturing, like blending, then granulations process and everything. So during this process, they test the product to check whether the product is meeting the acceptance criteria or not. So that is called a bioburden test. Once the products get finally, when the products get packed, That time we perform microbial limit test. So bioburden test generally performs for this intermediate testings, or even for the packing material, you can say. The microbial limit test is like last test after the product get packed. That time we do the microbial limit. So microbial limit test, bioburden test, both are. Bioburden test generally perform in sterile facilities, also non-sterile facilities. The microbial limit test is only for the non-sterile formulations. So this is the basic differences. Like in bioburden test is performed to evaluate microbial contamination. Microbial limit test determine the bioburden of certain pharmaceutical manufacturing sample, that is like a finished products. It is then the bioburden test. It is performed to measure the total number of viable organisms present on medical devices prior to their final sterilization. Means before the sterilization or before the packing, whatever we do is a bioburden test. After, once they get packed or once the product gets sterilized, that time it is called MLT test. For the sterile formulation, we don't do MLT test. It is a sterility testing. The bioburden test is either one or both of the Townpedial, TMC, TIMC, like bacterial count, fungal count. So endotoxin test, this is the last test I keep because this is a little bit. So generally endotoxin test is performed whenever we manufacture the product. Which is sterile in nature, and the product directly comes in contact with the bloodstream. Only for that product the endotoxin test is applicable. The product should directly come into contact with the bloodstream or the cerebrospinal fluid, what is called CSF, whatever, in the spinal cord, I guess. So at that time only the product is tested for the bacterial endotoxin test. And there is one more, if WFI, water for injection. So for these two, the product should be for that two purposes, like it is going to the intra IV route or intraethical route, I guess. So for that only bacterial endotoxin test is performed. So bacterial endotoxins, the theoretically you should, I think you must know about more about than me actually. So it is like gram negative polysaccharide, which we need to detect. So whenever the gram negative, for example, if we process the product like sterilization, all the suppose there are organisms, gram negative organisms, for example. So these organisms, the debris of these organisms even cause the clotting of your blood. So this was invented like whenever there is a like horseshoe crab blood is one person saw that there is a clotting in the horseshoe crab. So then after that it is get invented. So once, even after the sterilization, the endotoxins remains in the product. So to detect that, we perform this gel LAR test, like or you can say bacterial endotoxin test and LAR test. Both are the same, the different terminology. So what we do actually, I don't know how to explain you about the bacterial endotoxin test, because this is a little bit like. I will give you a brief idea about it. Like when, for example, we'll give an example of WFI, like water for injections. So when we test water for injection for bacterial endotoxin test. So what we do is we take a WFI, and there is called lysate. Lysate is what, like enzyme. For example, it is amoebocytes, you can say. So it is recovered from the horseshoe crab, the blood of horseshoe crab. So they take the horseshoe crab blood and they what you can say sort this lysate. So this lysate and WFI, they mix it, and we said just check the clotting of it. If there is no clotting, then there is no endotoxin present in the WFI. If there is a clotting, the WFI contains your bacterial endotoxin. So what in the laboratory we get the lysate. So lysate, from there are so many vendors who provide this lysates. From they take the horseshoe crab, then they take the blood, and they then remove this lysates, and they manufacture these lysates. So these lysates are having specific sensitivity. For example, 0.125 EU. EU is endotoxin unit. So how much endotoxin that lysate can detect? For example, if the lysate is having 0.125 EU of sensitivity, that means up to 0.125, that lysate can detect the endotoxin. If the product contains 0.125 EU of the endotoxins, the lysate can detect it. But if it is having lower value, like more than 0.125, the lysate can't detect that endotoxins. It is called lysate sensitivity. So if you see WFI, so WFI endotoxin unit endotoxin limit is 0.25 EU, 0.25 EU. And suppose if you have a lysate sensitivity of 0.3, so 0.3 lysate sensitivity or 0.6 lysate sensitivity you can't use. You have to use 0.125 lysate sensitivity or below that. So 0.25 lysate sensitivity or below that. So generally all over the pharmaceutical industry, or generally 0.125 EU lysate sensitivity is provided. So it is for most of the products 0.125 is enough. So most of the vendors provide 0.125 EU lysate sensitivity. Lysate having 0.125 EU sensitivity. So what actually does is we take, so for example, 100 microliter of WFI. Then we put lysate 100 microliter. There is a 2 times dilution. For example, WFI is having suppose 0.5 EU, not suppose, it is 0.5 EU. WFI is saying 0.5 EU endotoxin units. So you can dilute this WFI up to 2 factor, like 0.25 to 0.125. So you take 100 microliter of WFI, 100 microliter of lysate having 0.125 EU sensitivity. When you mix it, the WFIs get diluted 2 times. Okay, so if there is a gel clot, that means there is a more than 0.125 EU endotoxins present in the WFI. If there is no gel clot means there is a tubes in that 100 microliter WFI is added. Then we add those 100 microliters of lysate, and we keep it for 30 to 35 to 37 degrees centigrade for 60 minutes in a water bath. And then after that you have to take that tube and you have to swirl in 180 degrees centigrade turn. If there is a clot, it means it is failing. If there is no clot, it is passes the test. So it is like that. So for example, WFI is having 0.5 EU. So different product is having different endotoxin limits. So endotoxin limit is generally how they determine the limits. Like they are having a formula like K by M, the value, the human dose, matlab, how much human can tolerate in a per kg mass. For example, per kg of human mass, how much endotoxin limits, how much endotoxins can human tolerate, divided by the lysate sensitivity. So accordingly, the endotoxin limits are calculated. And once the endotoxin limits are getting, if you know the endotoxin limits, then accordingly lysate, you have to use the accordingly that sensitivity lysate, and you can add it, and you just check the gel clot. So I will forward you all this literature about the endotoxin test. So I think from my side, I have completed. I have tried to complete everything. And thank you very much. Over to Avinash.
Thank you, Mr. Avinash Rohidas, sir. Now the topic is open for discussion.
Hello.
Thank you, sir. Yes.
Hello.
Yes.
One of the participants want to ask some.
Hello. Avinash sir.
Yes.
Will you please explain something about media field studies? Media field studies.
Yes, media field studies, it is actually performed in a sterile manufacturing facilities. What media field actually we do is, so whenever there is a, see, this is, media field is like a process validation. There is a support, for example, I will give an example what we do actually. In a sterile formulation, we are having a respiratory product like form, fill, seal, that is FFS, form, fill and seal. Like there is a if there is a manufacturing room where the product get manufactured, then there is one pipeline comes to the packing area. There is a plastic granules. The plastic granules get melted, and they form a like how we get the vial, like that they form a shape. In that the product goes inside, and then this everything is a aseptic technique, and after that it is a packing. So what we do in a mediafill is, instead of a product, we fill the media, like soybean casein digest medium or nutrient medium, any nutrient medium. We generally in all the pharmaceuticals use a soybean casein digest medium. So we fill the media into that container, and then we incubate that container. So like instead of product, what we use is a media, so that if there is some problem in the process, the container will show the turbidity. Understood?
Okay.
So this is the same manufacturing process. Only thing, instead of product, we use the media and we incubated it. So after the incubation period, we'll come to know if there is any turbidity. We'll come to know there is something problem in the aseptic technique.
Okay. Okay. Thank you.
Yeah.
Okay, thank you, sir.
Yes.
By your creative presentation, which includes interesting animations, and with your gentle language explanation, the last session was also so much delightful for all the audience. So once again, thanks a lot for being with us.
Thank you. Thank you. What I feel is theoretically, I will provide you everything, like whatever literature you want to explain to the students. But what I feel is you have to prepare them for the interviews, because that is the most
Yes.
important thing. So whenever actually I take the interviews, most of the times, when what I feel is theoretically you know everything, like students knows everything, like whatever the gram staining, whatever you ask, they know about theoretically. But industry, if you ask me, I don't use a 1% or 5% of my knowledge, whatever I learned in the MSc and BSc. So what generally the interviewer sees is how much he can tolerate the environment of the industry, and how much he can quickly aspire all these things. So for that you have to prepare. Like environment monitoring is a very good topic for that. Then your microbial limit test, the bioburden test. Even briefly they can explain. The interviewer feels satisfied, like, and he knows something like. So if the students are preparing to get the job in the industry level, so you have to prepare with that thing. If their interest is in the academic level, there is no need to go for this. Then there is a, you have to go only this theoretical and whatever the research that you know better than me. So if the industry is your career, then all these things are very important, and it gives a positive impact, a positive impression to the interviewer.
Right, sir. So
Thank you.
thank you so much, sir, for sharing your views and your advice to many students.
Yeah, thank you.
Okay. So personally, I'm thankful for all the participants again for your time and stay with us. Today our workshop is ending, but we all are taking some wonderful knowledge with us. By ending this, last but not least, Mr. K. Sutar sir, he is going to give address about the vote of thanks. So I'm requesting him to address the audience with the vote of thanks.
Good evening to all.
Good evening.
Sir, your voice is
Good
audible,
evening
but
all. Hello.
Yes, good evening.
Good evening to all. Honorable Sri Prakash Pandurang Patil, Bapu General Secretary, Sri Shivaji Education Society, Board for Higher Education, Karad. Higher Education, Karad. Honorable Dr. K.D. Sononi, Honorable Dr. S.S. Pajikal, Honorable Dr. N.R. Sheikh, Honorable Dr. Shailesh R. Wahadmare, Honorable Sri T.B. Sawant sir, Honorable Mr. Avinash Rohidas, Honorable Mr. Tobik Tambedkar, and Honorable Mr. Valdik Patil, participants of this two-day online workshop on device for syllabus of MSc Second, General Microbiology, CBCS pattern, semester third and fourth, and the organizing committee of this workshop. It's my privilege to get the opportunity to propose the votes of thanks on this occasion. I would like to special thanks to the Honorable Prakash Panduran Patil Bapu for his presidential address. I also would like to thank to our principal, Dr. S.B. Kingar sir, for giving us permission for conducting this workshop. I also extend the special thanks to Dr. K.D. Sonone sir for his keynote address as well as sharing very valuable information concerned with the current research approaches. I would like to special thanks to Dr. S.S. Bajekal sir for explaining terms used in biostatistic and the knowledge concerned with bioinformatics, and also thankful for giving the information us of RDNA technology. I would like to thank to Dr. S.R. Vagmari sir for giving us excellent knowledge of enzymology subject. I would like to thank to the Honorable Sri T.V. Sawant sir for giving us explanation concerned with fermentation technology and industrial waste treatment processes and its references. I also extend the special thanks to Dr. N.R. Sheikh sir for delivering excellent information connected to the food and dairy microbiology. I would like to special thanks to the Honorable Mr. Avinash Rohidas for giving us idea or theme of the quality control microbiology. I would like to thanks to Honorable Mr. Tofik Ambedkar for giving us the practical knowledge of practical course practical course 6, unit number 2. And I also extend the special thanks to the Honorable Mr. Valmik Patil for sharing the practical knowledge of practical course 6, unit number 1st and 2nd also. I would like to thanks the organizing committee for this successful syllabus workshop. I would like to thanks to the participants of this two-day online syllabus workshop. At the last, but the not least, I would like to thank to the non-teaching staff and the Department of Computer Science of our college for providing this facility to arrange this workshop. The link of feedback form will be provided on your email ID on which you have been registered for this workshop. I request to the participants to fill up the feedback form. Finally, at the last, I declare the workshop is over. Thank you very much.
Thank you, Kishore sir.